Thank you.
Deep pleasure to have you here. I've known you for some time, and I must say, I think there are few, if any, that have a deeper understanding of deep learning than you do.
I'm nodding, but because I'm humbled. Sorry. Thank you.
But then, if you look at your LinkedIn page, you say, I have like a comfortable understanding of deep learning or something.
Yeah.
And then you're like a multi-year contributor to TensorFlow. I think you have a world record still in audio. What was it? Offset detection or
polyphonic pitch detection, maybe, but it depends a little on how you evaluate it, which is my current passion. How do we evaluate ML algorithms at all? So it depends always.
Yeah.
But thank you.
So it's kind of a weird kind of combination that, for one, you're a very humble person, but then having spoken to you a lot in the past, you're not always humble.
No, I'm only pretending to be humble. That's because you learned that you're usually wrong, and arrogance is very natural to me. So I assume I'm right, and then when I measure, oh wait, I'm usually wrong. Trying to pattern match that behavior.
Well, as a very techie person, I'm very much looking forward to this discussion and actually being able to speak about technical things in depth at some point. Yeah. So that will be funny, but Henrik here will he has promised to stop us if we go too deep into some kind of technical discussion.
Yeah, but I kind of don't want to stop you, but I want to explore with these techie minds also from traditional enterprise challenges. We have a huge landscape, and we do super techie stuff over here in our platform. But then I still have my finance and accounting systems. I still have this. So I'm really looking forward to explore how in quotation marks a modern startup type company. How does their topology look like? So in this way, I guess I will dumb it down to normal ERP questions as well.
Cool, but let's get started a bit quickly, and perhaps Carl, you can start by how would you describe yourself? Who is Carl Thomé?
Currently I'm working as a machine learning engineer, which implies that I'm a little bit worse at statistics than a data scientist, but I'm a little bit better at coding than they are. But I'm also worse at coding than a software developer. So
another
I'm a
humble comment.
No, I was saying my interest has been a lot of music, applied machine learning to music, but a primary interest beyond that is how do we actually get machine learning into normal companies. It's quite hard. It doesn't really happen naturally, and I think it's partially because it's very new to make it into industry, so you need to have a very broad knowledge. Everything from what the Poisson distribution is, honestly, but knowing about it, and also knowing about dependency injection, and then also knowing about how to even structure a team or whatever using GitHub Flow.
Speak a bit about object orientation as well.
Yeah. But all of these things, right? So my background is programming and computer science and web developer first, and then I went very hard into music because that's what I grew up with doing and listening to, of course, but also doing it a lot, and I think.
You play instruments?
Yeah, and it sounds...
Which ones?
Primarily electric guitar.
But he actually has a number of songs on Spotify as well with a rather high number of listens. So it's also another...
Can you bring that up, Goran, at some point during the day? We need to listen to it.
But in that, music technology is a very good mix, right? If you're interested in coding and you're interested in playing music, what's a good... the obvious mix then is how do we record music in computers? How does that work? And from being very young, I was always interested in like MIDI samplers, whatever is. What is MIDI? Who chose MIDI? What is that? And then going deeper into that, and now I feel like I'm kind of beginning a career where I kind of roughly understand the whole picture of it, that there's actually people behind all of these protocols and specifications, and the names of those people start to pop up in papers I read about machine learning, and it's a quite small world in a nice way. When you finally see like, I could write C code that probably records audio too and make it into a nice thing, and then apply this LSTM on that or whatever, and make a very exciting new sampler or synthesizer or whatever.
Super cool. When you say...
No, that's not it. That's another artist name, but yeah, sorry.
But when you say bringing machine learning into a company, what's your definition? Is it putting it in production as part of services?
No, services could be it. Or do you mean consultancy services? Because I'm thinking service as
No.
API.
I'm talking hardcore. I have some sort of digital service, and it's machine learning driven.
Yeah. That's roughly what I mean. So getting it into production, so actually having it in the hands of users, And that little step from working notebook to having it in the hands of users
is huge.
Yeah, it's huge. It's way bigger than making it work. So
yeah, and the whole discussion now, do we do machine learning that ends up some sort of as an insight that then people with analog synthesize the actions and decisions around, or do we actually put it all the way down into
all the way for me, I guess. So my goal would be to make it actually, I don't want to say automated, but the decision making could be scaled by machine learning suggestions.
And then production is also to do one data pipeline in production towards having hundreds, vertical scaling end-to-end data pipeline in production versus also vertically having hundreds of algorithms running small services everywhere, and you need to start thinking about feature stores.
Yeah, so all of those feature stores are a very interesting buzzword. I like it. I'm reading a lot about it because I have those problems daily. And I guess this means horizontally, not vertically.
Exactly. Right? So you're putting one product, and I think this is the story. We do machine learning. Where does it end up? Well, actually, I'm showing it in Power BI to someone to visualize my insight. But
that's a big part of it. Like when you say you work with machine learning, people don't know if you work with generating business insights, preferably actionable insights, or if you're working with APIs and setting up nice. I'm from deep learning, right? My history isn't working with classification so much. It's more a multidimensional output. So removing blur from images or whatever, and from your audio, right? So removing certain instruments from a mix or something.
But speaking about Power BI and perhaps analytics versus AI or something, do you have what's your view of the difference between the two, or are they basically the same?
Toolbox is going to be more similar as time goes on, since we're going to make the tools less hard to understand and hopefully and easier to use. And machine learning is a very useful tool for analytics and generating insights. So I think it's going to be roughly the same stack for the tech people, but obviously then the soft skills are very different. So if you work as a machine learning engineer, as I do, I never actually practice explaining what I do to people. If I work as a data scientist, I would say I'm mostly working on explaining stuff to people.
And I think this has been one of the conversations we had also we had Mikael Klingvall as a data scientist from Vattenfall, and he basically shares your view and basically thinks that we have different needs and purposes as a data scientist, explaining and really make sure we have the context versus actually making something work as an engineer.
Yes. So my mental model is that I'm a bridge between software developers. Those are my audience, I would say. So they exist. They're going to get a new form of programming on their hands, whether they want it or not, because it's useful, it's going to work, it's working already. Big companies are already doing it. If you are a software developer, you're going to have to learn machine learning in the next 5 years. Otherwise, you're kind of a dinosaur, I guess.
This we need to dig deeper into what you mean with that.
Yeah, but that's a strong feeling I have. And then so bridging the gap between software developers and data scientists, rather maybe data analysts, BI people, being that bridge, I would say that's where a machine learning engineer kind of fits in. Where it's like, I'm not the strongest in the room at anything, but I can translate between these two different audiences. And that's been a valuable thing, I think, that I do sometimes in organizations.
I think we even had this eureka moment where we basically said, you know what, one of the big problems right now is that we are not making a distinction between data scientist role of explainable insights, validity, reliability, the whole statistical storyline versus engineering stuff as a new coding paradigm.
But isn't that like 5 years ago, maybe 10, data scientist actually did mean full stack, but it's shifted. So the term data scientist today is slightly different from data scientist 10 years ago.
I think it's a huge maturity curve here of understanding the field.
And then everyone who was interested in backend, they went like, no, I'm not a data scientist because those people are stupid. And then they're like, I'm going to rebrand myself. So now I'm a machine learning engineer. And that happened naturally and organically. And now it's just a new phrase. I wouldn't be surprised if what I'm working with is going to be called something else in 5 years. When every software developer is applying Keras in their work in a normal way,
so why would basically AI will become ubiquitous or
it's going to be a natural part of many types of compilers probably. Like, you can optimize some parts of your floats. Yeah, all right, click.
But I think that has been also the conversation going on. I think really catching on the last 1 or 2 years that the distinction, just because you can do something in a notebook, it's not the same as putting robust software in place.
Yeah, there's quite a bit more to that discipline.
Yes.
And that's also a frustration, right? So I come from computer science as a background, which means I've been taught a lot about thinking about complexity, what that means. Complexity is a very broad term.
From a software?
No, not everything really. So operational complexity, I assume like having many people together. Why are we moving slow? Oh, it's easy to do it yourself. It's hard to do it with many people, but there's a benefit there too, of course. But thinking about complexity in systems is a very big part of computer science, theoretical computer science. And then coming from, or meeting data scientists can be frustrating because they are sometimes a very naive bunch.
Exactly, from
like,
the
just take my
engineering.
notebook, it's done. Yes, but my maintenance, we have to understand it half year later, can we? Those things are hard.
But can you imagine from a recruitment point of view, from a traditional company which is immature completely to the whole field, what a minefield this is to recruit for?
Yeah. So when I started at Epidemic Sound, and I didn't do an introduction, so who knows, but I'm working at a record label, you could say, or a royalty-free music catalog.
Epidemic Sound, I think.
Yeah,
we should do it.
Yeah, but let's continue now, and then we frame Epidemic Sound.
So for when I came in there as a full-time employee, aligning job titles was a big challenge. Like getting it well understood by the entire organization down to the tech recruiters, what these titles mean roughly in average.
This is a huge HR problem in all companies right now.
But like when you look from their side of it, it's like, how would they know that CNN doesn't stand for the network, it stands for the network? Like obviously it's hard, it's so many acronyms, so very weird, very narrow things. And like from a layman's perspective, you all work with data, you all talk about AI, I don't know. But they are very specific. So we haven't even mentioned data engineers, right?
No.
But that's also a very big part of it. And they are also distinctly different in my mind.
So data ops is not a machine learning ops?
Both. It's different, I think. But it's very, but it's like, and it's in my mind, it's clearly different. But coming outside as a CTO or something, looking at it, how would you even navigate all of these weird data disciplines?
Yeah, and then you put one simple dimension of efficiency. What's the balance between data ops, machine learning ops, data scientists? You know, even here, so you can understand. I think this is one of the main key challenges.
Yeah, and I think the gamble I'm doing at Epidemic Sound is that I propose that we should have very smart, more smart than we think, very full stack people initially. If we want to make this a normal part of the organization that have predictions and pipelines that predict stuff, then we will initially need a few super strong in all of these disciplines people, and that's super hard to find. So it has a cost. You can't scale in that way, but I think when you start, you need that to get anywhere. It's because it's so easy to accidentally have 3 smart people doing notebooks, and it never ends up anywhere.
No.
But it's also very easy to have people just doing data pipelines and never realizing that you could do shortcuts, like math shortcuts, or like, this is actually just this. Oh, easy. So you need a
person that can do everything.
Kind of. So that's a data scientist, I guess.
So this whole idea of how super narrow you are versus full stack has a lot to do with where you are in your growth as a company, or it doesn't even have to be company, maybe. Also in your journey of data and AI, because if you are starting out and you only have 5 guys to recruit in your budget, it kind of goes in this full stack direction.
And finding good people is hard because if you think about deep learning, it hasn't been around for that long, so no one has really battle tested it. Like what happens when the prediction server goes down? How do we handle that? Maybe that's normal software development. Maybe it's different. Who knows? I mean, having deep learning at medium scale at a medium big company, who has done that yet? Not many. Small companies, sure, they have an app, it does stuff, it predicts stuff, it's a one-off, it's working, and then big companies, the big 5, I guess, they have some stuff in production, obviously, but for us in between, there's many weird unknowns, or like operational unknowns, like which roles do you need to what degree. So what I'm working on a lot organically at work now is to make data engineers more interested in predictions, make software developers also more interested in predictions, but also maybe operations, and then make data scientists more interested in continuous integration, which I think is the easiest way of getting them to unit test stuff.
Wow, that was a lot of...
But like bridging those disciplines.
But you said right now to me was a lot of core things that we are talking about, but you brought it all the way down here. So could we dissect a little bit what you said now on a more less techie dimension? Because what you said right now was, I think, super important stuff.
I assume like outside of this little bubble of tech, where I am deep in tech, there are product organizations and stakeholders, marketing or whatever, yes. CRMs and all of those, and that's the actual end user, I guess, usually. And
the customer or the internal user?
Yeah, both. So many machine learning projects will probably have internal stakeholders and maybe end users as well, making nice newsletter segmentation, like which members should have as frequent mailing and whatever, churn prediction, all of this. A lot of the recipient of your predictions will be in-house.
Yes.
Although, like formally, I think for the team I'm in now, we have our actual end user, the storyteller, the YouTubers that Epidemic Sound sells to. That's our intended user. But on the way there, it's going to be, I need to get the CPO to roughly understand what supervised learning is, roughly.
Perhaps it's actually time to start to speak about Epidemic Sound a bit. We mentioned it a number of times, and I guess a lot of people don't even know what
is Epidemic Sound?
Do.
So that's been a big. It's a strange thing, actually. I think. Okay, so it's a record label to some extent. They have musicians making songs, and they put them up on a website. So that's a normal record label. But the end user here isn't necessarily you and me that's going to listen to this song. It could be, and that's fine, but it's primarily...
I'm actually using Epidemic Sound at home in the same way as Spotify.
Oh yeah, but many people do, right? And then also many of the Epidemic Sound songs actually are published to Spotify, and they are quite popular. So to some degree it's a normal record label, but the primary and the background, the primary revenue stream and then the history of the company has been production music. So that would be someone cutting together video, and they need sound effects, and they need some backing music. Some background music that sounds jazzy or something. So that's the history of the company. They started doing a lot of production music, and now it's more original music, so actually artists with their own sounds and their own identities, which are still used in YouTube videos a lot. But it's many different revenue streams at the same time. And that's a little confusing to me when I started. And on top of this, of course, there's something called in-store music, where you have, when you go into Kappahl or whatever, IKEA, I guess, they have music on. And they have to pay royalties somehow. And so either they pay royalties to the normal collecting societies, which is STIM in Sweden, or they pay a flat fee each month to Epidemic Sound, so they don't have to really think about it. And then they get a little kind of a Raspberry Pi that
and this
plays
piece
music.
Is sort of one competitor to you here is Soundtrack of our
Soundtrack your brand, yeah.
Right,
Spotify
this piece.
thing, but
that is Spotify.
Competitor. Yeah, there's also a lot of organic kind of intermingling between people. So like we had people leaving to Soundtrack your brand this month, and vice versa. I think we hired people from there too. Yeah. So in terms of people, it's not a competition, but I guess in money it could be.
But could you explain to someone who hasn't been inside the Epidemic Sound platform, how does it differ? Because I think it's quite different in the way you consume or search, or what the actual function is from other music streaming services like Spotify.
But that's the most subtle thing to talk about, really. It's like, isn't it? This is just Spotify, right? So why not just use Spotify?
No, this is a big difference.
There is, but it's very subtle, and it's like for production music. There are disciplines here where it's like you can be a music supervisor at a Hollywood movie production, and then your job is you're in charge of like which songs are we using when and where, and how do we pay for that, I guess. And they have a different mindset than I would have when I listen to Spotify. I listen to songs that I like, and I want to search for songs I like. But here we want to find songs that have a preserved same feeling of the scene, the video scene, after you replaced the music. So that's often it's probably very similar, but sometimes it's not. So you could probably go a little further away from timbre, or how the emotion of the song is more important, I guess, for Epidemic Sound, maybe than the actual singer's timbre or how he sounds.
Yeah, but even the whole idea that you're searching on moods, or you're searching a music catalog from a completely different angle.
But Spotify also has mood-based listening, and it's very popular. So it's like when you start Spotify today, you click on a easy slow piano, and many people do click on that and they love it. So how is that different? But there's gonna be video scenes that make this music work slightly differently. I'm not so sure that we can't use models from Spotify at Epidemic Sound and be very happy. Yeah. I think we have a natural overlap as well.
And then you have a catalog of sound effects.
Yeah, that's different, of course, right? So there's other audio beyond music. But Epidemic Sound's primary focus has been the music. but sound effects are also part of it.
And then one last very cool feature to cut down the different stems of a song. That's pretty cool.
Oops.
How does that work, by the way?
It's manually. So every music producers, when they sell their track to the catalog, they have to bounce out stems.
And what is stems?
Stems is so a few instruments solo of the track.
So you can literally
drums only or vocals only.
You can listen to the sound and take away the drums.
Yes. And that's a very nice supervised target for deep learning. So
here we have something to work on.
Yes, definitely.
Single source separation, right?
Single channel, yeah.
Yeah, single channel source.
Or
separation.
actually, in this case, it's stereo recording, so we could maybe use stereo imaging also, but I don't know.
I'd love to dig more into the deep learning part of that. And
yes, please.
Let's
do that.
But I think everybody gets the point with Epidemic Sound. Hopefully.
To me, it was surprising that you could make so much money on it. But then when you look around on YouTube, which is one of the markets where they have users, right? So the storytellers on YouTube, they use music. They buy music from somewhere, sometimes Epidemic Sound. Those channels, like I have a little fishing channel in Spain, and I have as many subscribers as there are citizens in Sweden. It's like the scale of it.
It's amazing.
It's amazing. It's also strange. It's like, oh yes, it actually goes around. You can make a lot of money. There's a lot of revenue in just having like these very small but still huge channels. There's billions of people in the world, and that surprised me when I started. The number of employees, for example, like how big is this business? Very big.
But also, I mean, to be fair about Epidemic Sound, I mean, it is one of the premier music providers for most YouTube videos, or
yeah, in terms of quality, high quality is the gamble to have high quality sounding music.
So in short, if you listen to some kind of YouTube video and hear the music in the background, it's probably from Epidemic Sound.
So that happens to me every day now when I'm watching YouTube videos. For some reason, I'm watching bicycle videos, whatever.
Mountain biking or what type of biking?
Like the Global Cycling Network or whatever that channel.
Yeah.
But so every description of every video, it's always like music from Epidemic Sound. And I noticed that when I like remembered like, oh wait, this test track, I've heard this when I was modeling stuff in a notebook. Oh, they're actually they're a subscriber.
And then you have some quite big YouTubers who are even, I guess, sponsored. Like Peter McKinnon, I would assume.
Yeah, so he's an ambassador.
Ambassador of Epidemic.
Yeah. And he's a photographer, right? I should know, but I don't.
YouTuber, photographer.
Yeah, but so and he has a couple of Swedens of subscribers. So it's a big world.
Yes.
I mean, it's so many different topics to dig into, and I think one is just the organizational change necessary to start using AI properly and not use it for the wrong things, but the right things and everything. And I think we can take that a bit later, and I would like to just dig a bit deeper into some of your previous work that you have done as well. You can choose a bit what you prefer to speak about, but it can either be this kind of record that you held or hold. I'm not sure if it's still the world record. It's probably beaten this year. Yeah, but that's fine, right? It's good. So to try to describe, what was that kind of challenge? Okay, so let's say I have an iPhone and I have a microphone. I record you playing piano in the opposite side of the room. It would be pretty cool if I could get out the sheet music just from the microphone signal. Sheet, so basically MIDI music from that. Yeah. Or so really sheet, you mean? Or? Sheet music would be the actual goal.
The actual to go to the notes, to see the notes in the sheet.
That would be fantastic. It's like just having your phone on in orchestra hall and give me the sheet music, predict the sheet music, and if it's right enough, then I would be very happy. That would be very cool, very useful. And so that particular challenge that I worked on a couple of years ago was as a downstream. No, it was a subset of this where you only predict the MIDI signal, which is almost like sheet music, but it doesn't have. It hasn't designed and picked a couple of things first, but so going from audio to MIDI, you could say a wave to MIDI converter.
And what is MIDI?
MIDI is a symbolic representation that computers use to play music, right? So when you in the 90s when you played the
Duke Nukem, MIDI interface.
Yeah. So when you played Duke Nukem 3D or whatever, and you could have different sound cards, and they sounded different. It's because the actual audio file wasn't there; they only played back the MIDI file, and then they triggered whatever samples or synthesizers you had on the sound card. MIDI is a symbolic. So you want to go from raw audio data in some kind of high frequency sampled version to some kind of MIDI prediction.
So how do you do that? What was your approach? And don't be too afraid to go a bit techie here.
No, but so what's interesting when you look at it, if we had graphics here, I could show it. But it's when you look at the spectrogram, which is then a time frequency representation of the audio signal, meaning at this particular time step, how much bass is it in the signal now, and how much treble do I have just now? And then you can make many of those slices over time, and you can plot them, and you get a nice heat map. So over time, you see.
So you can convert basically audio to some kind of 2D image? Or?
Yes, precisely. Right. So you could see that as a 2D image when you look at like how strong is the frequency at each time step for this little signal I measured, and that's a very normal, old, nice thing that we use a lot everywhere. But then when you look at it, it's like, oh, this looks quite close to the fundamentals that we have here, the pitch that I perceive. So it's almost done. It's almost midi. It's almost a done piano roll. But the only thing you need to do now is to remove some of the strong signals in the heat map, because they are combinations of fundamentals, and some of them are maybe.
So what is a fundamental, by the way?
What is sound, I guess, right? But it's then going to be like a sine wave when I'm whistling. I whistle at a specific hertz or specific rotation per second, right? And sometimes you have sounds that have many overtones. The fundamental would still be then the lowest frequency of those.
Yeah. And then it's a number of overtones above that.
Yeah, and many different. Some are harmonics and some are not, and there's a lot of complexity to it when you actually look at it. But it's a nice mental model to just think like the pitch is almost the fundamental frequency.
And if we are to just be or make some people listening that are really into audio tech kind of technology, what type of transformation do you use to actually get the spectrogram?
Right, so that's a deep learning thing, right? That's a convolutional neural network.
But before so how do you actually get the audio from like raw audio into a spectrogram? I mean, SDFF or SDFT or CBT or
so I don't
do
know
you metal
if,
spectrogram or do you use
so all of those are basically the same for deep learning. So it's some form of 2D representation where you have frequency on height and time on the width. But for my case, I use something called constant Q transform. Which is musically motivated, or it can be when you choose the basis functions, but it's not necessarily something we have to go into here, but it's very nice. Librosa.cqt, beautiful, very useful. If you know you have a musical signal, Western music signal, I guess, because there's many problems there.
What is music,
Yeah, exactly. That can go very broad. But the method I used for predicting then the MIDI signal is, it would work with a normal short time Fourier transform. It doesn't really need, I think, much of the shifting around and all the binding and stuff. MEL spectrograms are nice because they are smaller. They maintain most of the interesting parts, we assume. But theoretically, you would get very far eventually by just take the audio signal. Why even do spectrograms, really?
Yeah, you would have an end-to-end kind of.
Yeah, and people do this a lot, and it's like it's scaling, kind of not yet, but it's gonna probably work. And we know, like theoretically, that's the lossless end-to-end signal, so that's probably better in the long run. So it's a trade-off of like I don't want to wait for months to see my result. Okay,
so your approach when you took the world record was basically you transformed the audio to a CQT transform.
Harmonic CQT, so you stack a couple of partials in channel depth for the CNN.
What is CNN?
A convolutional neural network, right? Or the network on that broadcast news.
CNN.
I didn't specify.
And what is a convolutional?
So like if you just theoretically, it's hard, but you could just think of it like you're doing a bunch of Adobe Photoshop blurs, sometimes sharpening. It's the same math. Sometimes you'd make the image you have a little sharper in some directions, a little blur in some directions, whatever. We have the math for that. And here we use that, but we say exactly how much you want to blur or sharpen the image in multiple passes, and then you're going to downsample the image and make it smaller and stuff. How much you want to blur it and stuff is going to be determined by a bunch of examples of input image and output image to make the input image as often as possible look exactly like the output image. And that's not hard to do, right? But then the goal then is to make this, when you get a new input image, you want to have the output image still be close to some ground truth label you had. And that's where it gets hard, I guess. Generalization is hard. But fundamentally, it's not weird at all. It's just like, I'm going to do a bunch of random blurs. I'm going to make them less random to get out the target image more often.
Okay, audio, CQT, CNN. What type of CNN do you use?
Actually, convolutional LSTM. But I don't think it really matters much. What's nice about the convolutional LSTM is that it has very low latency when you want to predict stuff. in real time. So you only have to wait on a single frame. In this case, it's a CQT, so it's still a time lag of a couple of seconds. But if it had been short time Fourier transform or like a log MEL spectrogram, then you could do like 10 or 20 millisecond time lag at test time when you predict what am I playing now when you're listening to the audio. And that's kind of why I went for it. But then in the state of the art, it's going to be still that you're going to listen back in time as well, because it's easy to predict what you played if I hear what you're going to play. And that feels like a implementation limitation that I didn't really want at the time.
Okay, so you
go
from...
what was the actual record? Sorry, I don't get that.
You measure like on a test set of a couple of playing flutes and clarinets and violins. There's a test set that's on a hosted site in the US where you submit your code. They run it on those audio files and they match it to the sheet music they had or the MIDI file they had, and they say, you got these notes right, you got some notes that weren't in the transcription, you got some notes, you missed some that were, and then you just measure accuracy.
Percentage accuracy towards reality.
Yeah, so, and that's also, I guess, a discussion point, right? That data set, that test data set, is it fair, is it useful, is it relevant? Who knows? Okay,
just to close the loop here, so input, the raw audio, CQT, you get basically two-dimensional spectrograms. Then you have a Conno LSTM that predicts something.
Yeah.
And that something is basically the MIDI symbols? Or
a piano roll, which can be easily converted into a MIDI signal. So a MIDI signal only says what note should... It's a stream of events that says how long should I do this? And that's the event. And in a piano roll, you have a discrete time size and you render a matrix. And that makes it very natural for deep learning. So you could just say this 2D thing should become this 2D thing. And they even look similar when you just look at them. Like if you gave me a marker, a pen that I could highlight stuff with, I could almost do this manually. So it's like when you look at it, it's like this is an obvious fit for convolutional neural networks. And I guess you would call it semantic segmentation. So it's a 1 in the output matrix if the pitch is present at the time, and it's a 0 if it isn't.
So as a layman now, has anyone tried to sort of beat this record with a completely other technique?
No.
Or is it always the CNN technique?
No, that's a good question, right? So historically, people did a lot of stuff that required a lot of domain knowledge about pianos or acoustics or music, and that worked well. But it's easier to just not know about that and just have a lot of examples. So every paper that I see now does some variant of using convolutional neural networks. And how do you beat? What would you do today to beat your own score?
Good question.
So, for example, I would make sure that the piano roll I predicted, if I were to make it back into a piano-sounding thing, I rendered it with a sample library of piano tones. I would really love if that resulting audio signal sounded kind of similar to the input signal, as a nice extra loss term or something. And this is not my idea, but it has been, whatever. But it's a very good idea. Like, you make sure it's consistent. Like, it should sound the same what comes out. And then you have concerns about, but the sample library used, that's a different piano, so it's not going to sound exactly the same. But that's still going to, minimizing that distance will still be useful, probably.
Couldn't we simply use a GPT-3 for this? Or?
Yeah, sure.
Sorry.
Yeah, could you go a different way?
So transformers is a very hot topic.
Yes.
And people use that.
Yeah.
I see that a lot. So why was it an LSTM? It doesn't have to be.
Even for two-dimensional kind of inputs, you can use it.
Yes, definitely doesn't have to be an RNN at all. I think I like RNNs because I like the theoretical guarantees that it can learn. It could learn to parse JavaScript.
And I just want to make sure that people understand. I was ironic when saying GPT-3. Some people may misunderstand.
No, but I catch on to it because everything can be done with GPT-3.
No, we can really not. So it's important to make sure. Okay,
I'm just skipping that one.
Yeah, surprisingly, Carl didn't comment that. But, we had a discussion before.
And we shouldn't assume that people saw the last podcast where we had a lot of discussions on GPT-3. So what is GPT-3?
Yeah. Okay. So
you only get 10 seconds.
Auto-regressive language model. Yeah.
It's one of the biggest models ever released. I think Google has had a bigger one very recently released that is 5 times bigger. But still, it's hundreds of billions.
Google it.
Hundreds of billions of parameters, trained in a very simple way, and can predict the next word in a surprisingly good way, and used for
this kind of generalist tasks.
Okay. But it's not for every kind of use case you can think of. No. And I just want to make that clear.
And now we stop it. We talked about this already, but just for reference. Yeah, we use acronyms, so that's why.
Yeah, GPT isn't even an acronym at this point. It's more like a word. It's a noun at this point. It's weird. It became such a mainstream noun.
Yeah, exactly. So this has been so much now. So what does it even stand for?
Yeah, exactly. Who knows? It doesn't it doesn't. It's a word now. GPT-2. All right.
But it does stand for generative pre-trained transformers. But anyway, doesn't matter.
I guess the keyword is transformer. And transformers are interesting, but I don't think, like whatever you use for sequence modeling, it's still gradient descent and you still optimize something with backprop. So I don't like in that part of it. It's not that interesting to me.
What do you think?
Sorry, guys. What's the idea of a transformer? What you are throwing this too fast?
It's not a car that turns into a robot. I don't know if they even named that because of that. It could have been.
The transformer, that's what I thought.
I usually use that picture of the
What
transformer.
about G Autobot T3, right?
Yeah.
Now we confuse people even more.
Yes.
But so the core part of transformers, if I had to say it in two sentences, it is that you make the model care about where the input that it wanted to use, where it was, right? So it has attention. So like, the part of the sentence where there is important stuff for my prediction, maybe I should look at where it was and do stuff about that. And that's a very layman's kind of, But attention is so attention is a normal word, it can mean many things, but just like what part of the input was relevant for making this prediction. And maybe we should exploit that there's a stronger signal in parts of the input for this particular prediction. Maybe the model should be aware of this. And that's a very super high level explanation. But so RNNs also kind of do this, and you can have attention in many types of networks. It doesn't really matter, right? But so I think the actual reason we have transformers now so much is because they don't lock the next time step. They scale super well. They're very fast comparatively.
So just to comment quickly about that, I mean, Google had this paper, self-attention is all you need. Very controversial kind of title for it, basically saying you don't...
Attention is all you need.
Attention is all you need, but
attention is... This sounds like a Beatles song, yeah?
Yeah, not attention.
attention.
Yeah, but that one,
But basically says you can use self-attention instead of recurrent neural networks or convolutional neural networks. But we'll see what happens in the future, I guess. But do you think... they can be used, they will basically replace RNNs, for example, in long term? Or?
Nah, I think it's different stuff. I think we're going to see models that have a little bit all over everywhere. So the whole differentiable functional programming paradigm, where it's like, maybe an RNN is good here, because it's a parametric reduce function. Now, we want to reduce this list to a single vector. We don't know how. Use the parametric reduce. And it was called RNNs 10 years ago. And then we're going to have in the same network, you're going to have a couple of transformer modules and mix around stuff, and some are pre-trained, some are not. And you're going to take that from a marketplace, you're going to fine-tune this part, you're going to take this computer vision module and use this machine listening module and combine them. You're going to play around with it a lot. I think that's the future of it. So fundamentally... Mixing, hybrids or whatever you call it. So like when people say there are CNNs and then there are also RNNs, I feel like more like it's a symbolic expression, it's a differentiable expression. And that's it. And then you can have many types of, as long as it's differentiable, and just minimize whatever objective you had. And that's, I guess, core deep learning. And then the questions then is like tractability, or where do we start? This search space sounds huge. And that's why we have graduate student descent.
So that's actually a good segue, I think, into another topic.
Yes.
I'm not sure if you've seen one of the Lex Friedman shows with Jeremy Howard, the founder of Fast AI, and he was, I think, previous president of Kaggle as well. He basically said most research in deep learning is a complete waste of time. Yeah,
but he's right, I guess. By the way, I still have to do it, so whatever.
Do you think that there is a way to improve the focus done in deep learning research to make it?
I mean, if he meant papers where you add a couple of more layers to a thing, and you had a baseline which says CNN, you had some layers and you had this little extra auxiliary classifier loss, whatever, and you see that you get a little improvement on a test set.
I think he refers to you want to have the frenzy of coming in top of the leaderboard of some kind of old type of data set somewhere, and it's not really focusing on actually operationalizing or getting value for the value in a company in some way.
But we could have research on that too.
Yeah, exactly.
So the world is very big. I don't mind that people are curious about how far can I get with as little data points as possible. How good can I generalize for having article classifiers?
So that's actually one of his favorite topics, active learning, as we spoke about. So really, that's one of what he says one of most important topics to actually work with and do research about to have true value in a company that actually make use of AI properly.
The assumption then is that the data comes from something in the real world, so you can't use self-supervision.
Yeah.
Because that's also like
still use that, but okay.
Maybe for pre-training, GPT. But self-supervision is my favorite.
Yeah, I mean certainly.
And that's where deep learning scales, and ultimately have to think about like, well, how did you label the data? No, it's explicit in the Python code, so we don't even have. We can't git commit to it. If you want to change my assumption of how the targets relate to the inputs, you git commit.
Try to give like a layman's description of self-supervision.
So a colleague said a fun sentence that I liked yesterday on a presentation. He said it's where you have supervised learning, but you withhold some of the data, and that's like I guess it's true, but it's almost easiest with an example, right? If I had colorized photographs, I know how to program a black and white version of that same photograph. That's super easy. I remove one of the channels, or all of them, or have one left, and I do a mean of the channels, the color channels. But then going the opposite direction, like how do I do that? I have no idea. I mean, as a human, I would do it. I could do it with a colored pencil. This looks like a dog. It's probably brown or gray. And this looks like a tree. It's probably green or brown. I can do all of these things, right? So there's some signal still in the grayscale image that would be helpful to predict if predicting colors. And going the opposite direction then could do that could be a machine learning problem. Nice. And now since it's easy to generate my inputs, I can always destroy colorized photos and make them black and white. I have essentially infinite training data.
So why do you have such a passion and interest in self-supervised learning? What do you think the advantage is compared to normal supervised learning?
Yeah, so in normal supervised learning, I guess it's implied that you need humans to annotate stuff. Yeah. And in this case, you're going to go, no, I'm going to script my annotator. So I am the annotator, but I do it with a Python script.
To automate basically the annotation part?
Pretty much, yes. Exactly, I guess. And then in self-supervision research, they also often talk about a downstream task. So this pre-training isn't the end goal for many. So you train a computer vision model on colorizing black and white photos because it's actually going to be good at saying which cancer this is in this image. So that there's some downstream task after the pre-text task. But for me, it's like, I don't know if that's important, the self-supervision task, if that's the goal, awesome. And the most obvious self-supervision thing we have, I guess, is autoencoders, right? Like, how do you label the data? It's the same. It's going to be itself. Yeah. That's very easy to script. You don't even have to script it. Yeah. Just connect the input to the output. And
so basically it makes it easier for companies to train models because you don't need
data scaling problems, So you can have as much data as you need.
Yeah. And you don't need to annotate data, I guess.
Yes. So I have a project now at Epidemic Sound about music similarity. Yeah. And then there are popular modern self-supervision approaches, but they do make it or break it on the assumption of what is similar. So you're going to have maybe like a triplet loss where you want to say like this part of the song goes into my forward pass in my network, I get an embedding, and it's going to be close to something, some other song that went through the same network. And it's going to be far, I want it to be far from some other song segment part, whatever that went through the same network. So it's just like a standard triplet loss. But then you have to select like what is similar, what's a positive example, what's a negative example. And then you have to have some domain knowledge still. Which
you don't do it manually still, do you?
Yeah, no, papers are going to go like, so we assume for our domain, for our type of audio signal or our type of image or whatever, we're going to assume that changing the hue is still the same object, or changing the pitch is still the same mood. Yeah. So you can have those invariants, and then you get a nice self-supervision loop where you can like augment or destroy the data and say this is still the same, so it still should still be positive. Yeah. Or the same with negative, right? So if you destroy the data in a certain way, you could design it to say this should not be similar. That's super powerful.
Are we lost you yet, Henrik, or is it?
Well, I'm starting to drink beer more than listening. I was zooming out now.
But what's nice about it is that you don't have to think about the relationship between inputs and targets. It's explicit.
But let's do this. So, what's the application of what we're talking about now? So what's the main application of these?
The most famous product currently launched like last month is NVIDIA's DLSS 2. So that's deep learning super sampling 2.0, whatever. which they launched now with the new graphics cards, and it's very nice, and everyone's very happy, like, oh, it looks so good. And the AA stands for anti-aliasing, so removing sharp edges in a 3D picture of a game, right? So making my Counter-Strike Go match look even smoother. Without having to render the game at a high resolution and then downsample it, because that's the old school approach, right? Just render it in a higher resolution, and then when you're going to downsample, you can make it in a smooth way, because you have more pixels to work with. Or you do some random small multi-sampling, super sampling, whatever, many techniques. Here we just say, I can parameterize the smoothing, the edge detection smoothing thing, by just rendering the game, scenes from the game, offline. I don't need to have a high FPS for that. It could be 1 FPS, a kind of a server farm. It could be an extremely expensive computer cluster. So, and that's fine, as long as the forward pass that results from this is faster or prettier looking at the end result than the current best anti-aliasing approaches. And at this point, with the 2.0 release, I think it's like, it looks good, right? It's like, it's very easy to get the training data, just render the game in high resolution and your normal resolution, and then you predict from one to the other. It's obvious self-supervision thing, right?
But I had another question. So maybe we're jumping now. If we can take it later, but I want to come into what's the main opportunities or CNN work you're doing for what purpose in Epidemic Sound?
Yeah. So
is that the right time?
Yeah, no, it's perfectly fine.
Yeah. It's a very broad question. But
so what are you working on, and to what's the customer application that you're trying to figure out?
We have many projects at the same time now, so I'm a little confused. So one part of it is that Epidemic Sound wants to scale, and when you scale, it's going to be probably hard to have humans doing decisions. So we want to make them faster, not necessarily replace them. That's not the goal. But if you could give them initial suggestions for their ordinary work, that's great, right? So, like, oh, which people should I send out the newsletter to? Oh, probably these. Okay, if that system is helpful and good, we're very happy, and that's probably machine learning or data-driven. So for me, it's been a lot about Epidemic Sound wants a bigger catalog. We want to work with more musicians. We want to take in more songs. Those require manual review. Like, are they done yet? Do they sound good? And also like annotations, so they are searchable and browsable. So someone has to fill in which instruments are in the track. Someone has to fill in which mood it is. It's quite hard, probably, for humans to fill in the mood consistently and the same way every day, because maybe you're sad one day and you're a little different that day and whatever, or you change employees and they have different.
Or simply sheer size to do it at
yeah, even the speed of it, right? But for Epidemic Sound, I'm not worried about having like 10 tracks per second. So you're gonna have time to do it, but it's not the most fun work to do. And if you could get some nice initial suggestions of like, this is obviously sounding like a pop song with a guitar, please confirm.
That's a nicer work. A perfect example of like using AI together with humans is really the best way to do it. And as
that's the only way I would do it, I think.
Yeah,
that's interesting. Do you think that's the way? Yeah, elaborate on that.
Okay, so autonomy should remain in the hands of the user. I think that's gonna feel very important. I have no reasoning for this. It just feels like it's gonna be more important than we think. And there are definitely machine learning applications where you can't have autonomy in the hands of the users. So a recommendation system is the obvious one, where I won't have time. I can't personalize recommendations to all of our millions of users. So we're just going to roll with the initial suggestions we got, and we're going to send them out. But if I could use a human in that loop, I would. And whenever I can, I want to, because working with machine learning, there's many problems with out-of-domain examples, like how do I detect anomalies to just abort, or what do I do? Can I have tests skew over time? Probably. Maybe not for genres, because musical genres don't move so much over time. Over 10 years, yes, but not daily. But we're talking about churn prediction. Am I making good predictions? Yeah, I guess I need a label for that. Who gives me the label? Probably a human.
Cool. If we go to a bit more like philosophical question perhaps, but okay, we want to use AI together with humans, when possible at least. And we can assume that humans are good at some stuff and AI is good at other stuff. Do you have any sense for what stuff is AI good for that human may not be good for, and vice versa? Yeah,
I mean, AI is since the AI effect, it could be that AI is actually as good as humans at everything in 10 years. So, when we
that's another interesting question, by the way. But
when we talk about deep learning or machine learning and stuff, where you do pattern matching and just finding similar stuff across instances. I would equate it to being like you have a colleague who you don't you know they're not the best of the group, like they're probably actually the worst of the group, but they are so quick and they get so much done, so it's still useful. Like, oh, so wait, I spent one time with one customer and you've gone through 100 customers already. Whoa, that's very fast. There's value in being fast. There's value in being consistently stupid. And then we can work around those hard examples to classify. So maybe we should just, I don't know, I like saying like scaling human decisions by providing initial suggestions, right? You're not automating anything. The prediction for me is a suggestion.
So perhaps
and
another
you
way
can take that into so many different fields, of course.
Yeah, so this is for any type of machine learning system. I would like it to be a suggester. It suggests, and sometimes it even goes out to production, but it's still a suggestion. Yeah. So when you see an end user product feature, it usually says for recommended for you by our machine learning whatever.
Empowered something.
Empowered,
yeah. And that's a very good. It's a very important sentence to have.
Yeah. So okay, sorry for another more like philosophical question, but. What would you say the major differences are today with the human brain and deep learning systems?
What do you say? Different neurons, softness, spiking. How much do we know about the brain? People maybe do. I know nothing. How do I think? I don't know.
Yeah.
I think, and I think well sometimes. How? I don't know. I like that there are people thinking about this.
I know you said you're going to try to turn the tables here, and I'm very eager to actually speak about that, but I shouldn't really do that.
We need to. This is coming back every time. Speak up.
Okay,
what do you think?
Why do we care? Why do we care? I have a toolbox. Yeah, it's good. It's useful. Why do
you
I
think
care?
we should move closer from deep learning to human brains, or should we move in another direction, you think?
To make what? What's the goal?
Why do we care?
More use.
So we want to make, like, if we want to build AGI,
more value from a company point of view, for Epidemic Sound.
Yeah, so if Epidemic Sound or a company now today wants value, machine learning is ready. It has been for decades. It's been good for decades, and then deep learning has been good for 1 decade, right? And it's valuable today. So you can build these things; they will be very powerful. You could disrupt competitors.
There are still challenges with deep learning, right?
So not in terms of making useful product features that work good enough, if you know the constraints of it. So if you think about deep learning methods, not in terms of AI or intelligence, and you think in terms of pattern recognition and just finding similar patterns in a big chunk of data, then it's already useful.
But
useful, yes. But what should the next direction be to make it even more useful, even more valuable? You know, what are the best ways?
Yeah, I think actually, like, if we started using it, we haven't plateaued at all. And like, I've been in deep learning for maybe 5 years now, and it's still surprising that we haven't even started building stuff.
Yeah. And
like
why do you
the
think
short
that
list
is?
of good ideas, like this should be an app. Why isn't it?
I think Epidemic Sound is actually one of the best examples of companies actually starting to use AI properly. So, but still, I guess there are challenges to actually making even more value from AI. And if you were to try to just think about that, what are the main challenges to even increase the value of deep learning in Epidemic Sound? What would that be?
Use it more, not make it more sophisticated. Is that what you're saying? Sorry.
Kind of, yeah. Kind of. Like in terms of pattern matching, this toolbox is good. And then AI people interested in reasoning and this, they could still work on that and research that. And that's not necessarily ready for applications yet. And that's fine. I love that there are smart people thinking about how the brain works and that they share what they know with smart people thinking about how machine learning works. But that feels so far off. From if you have a day-to-day where you try to implement a nice recommendation system that recommends songs, why even think about how your brain works? Like, it's so far out of left field. I don't know.
I really resonate with your simple example. Simple
I'm
question.
A programmer. So.
No, why? Because I think this is a little bit like: are we on the 2030 agenda or are we on the 2020 agenda? And I think the problem is right now that we end up in these huge conversations on ethical AI or AI AGI, when actually what the whole idea is literally, how to get value out of deep learning and neural networks and all that. Why don't you simply learn enough of what is in production or usable today and simply apply it to those skills and like that? Because I think the more we talk like this is the 2030, this gap of what is reality and what can be done just gets bigger and bigger. When I simply say just get started, mature, use what is out there now, and then by using it and learning it, you get value here, and then you will progress. You will naturally push the boundaries. So I resonate with this stuff because I feel like the conversation becomes more and more and more philosophical instead of becoming more and more.
It tends to, yeah. And we can do both. I want really
we need
strong,
to do both.
I want super strong basic research funded, and I want super smart people thinking about what they want to think about deeply and be able to do that. That's very nice. A society needs that. And AI researchers, I love the topic. It's very nice. But working with machine learning, I apply it, and it's useful already.
And what's the challenge is to simply apply it today?
So the challenges are way different from the thoughts about how does it reason, does this pattern matcher work or not? I mean, I know it works, it does work. It generalizes surprisingly well to my quite hard test set. So I'm kind of done, but then I had the work in front of me.
And now what's that work?
Exactly. Yeah.
What is that work? Because I think before we turn on the cameras, what are you working on in reality in a place like Epidemic Sound that is even quite mature compared to a lot of other companies? You're still working on some of the fundamentals around change and organization. So I'm curious, it's great. Your work is done, but your work is not done because now you need to educate, you need to bring it into production.
So my proof of concept is done. I can commit to trying to do this for real now, and now my work starts.
Yeah, and what is that?
Yeah, and that's a very hard question because I don't really know. I think it's a lot about understanding between people. So getting predictions into organization, it comes with uncertainty. That's kind of in its nature, and being robust for uncertainty and knowing that you won't know if you were right before a certain time frame has passed. That isn't natural for many organizations, right? You take a decision, you have a history maybe, but the decisions are now, not eventually. So it's, I don't know, like I have OKRs, right? Does anyone, I guess OKR is normal?
Operational
objectives and key results.
Objectives, key results, OKRs.
But so like measurable, attainable goals over a year or a quarter.
Key results.
Yeah. Acronyms.
We need smart OKRs.
But smart actually is another acronym, but that's another story.
Yeah. So
specific, measurable, attractive, realistic, timely.
Something like that, yeah. Not sustainable, I guess. But in OKRs, you go. My current one of them is to make machine learning a natural part of Epidemic Sound, and that's not measurable necessarily. Like it's more a gut feeling check. Are we? Yeah.
But you could put metrics on how many.
Definitely,
how many
but then the
algorithms is out there.
Yeah, definitely. But then the point isn't necessarily to have it measurable. That's an exercise. I think the goal is to just have aligning like where are we going? Do we have a shared idea where we're going? And the OKRs are just a vehicle to facilitate that alignment. And now when we landed in this OKR, like we want machine learning to be a natural part of our organization. This involves, I'm going to start small. So I'm going to start with tech people, and that's hard enough. And then we're going to go into the chief marketing officer. There's so many divisions, different departments doing different things. So, but the goal is still like they should all understand that certain types of Excel sheets, certain types of data streams, and certain types of problems are super easy to solve if you know that you can predict some stuff.
And now we're back to sort of that's what we said before the camera is a little bit like we're working on the same problem. I'm working on this problem in an enterprise setting, and you're working on it here. And what in a way also humbles me is that I think to people looking from the outside. Epidemic Sound is one of the few guys who are positioning and doing stuff with AI, and they're quite mature in this. And still the fundamentals of going on a data and AI, I call this the data and AI readiness journey. So to apply ML is about organization, ways of working, thinking, differently about how you looked at a problem before and you need to learn about how to apply machine learning, all that. So essentially, even in one of the most sophisticated companies, I would say, perception-wise in Sweden, around actually you have done quite a bit. You're still on that same journey, maybe a little bit further than a traditional company, but the essential journey doesn't go away.
No, probably not. And so you have to have a belief or an ideology that these things will be good or useful. for my bottom line or for the world and
to push and to persevere.
Yeah. So I mean, then you go like, why does Epidemic Sound focus on data science? Partially, it could be because competitors do it, right? So like there's some FOMO. You want to be relevant, and if they do it, maybe we should too. But but I still feel like in this particular case with this particular company, they have thought it through a little bit more than that. Like we don't only do AI because it's cool and everyone else does it. It's because there are particular pipelines that should and will scale very well with a little machine learning scikit-learn model in that loop. And the tech is quite ready. But the journey is still going. And I don't feel like we have gotten that far as I would like. I guess that's never true.
But this is such a, how should I put it? It's all relative, right? So you're talking like, the nerdiest guys, the nerdiest conversation I've heard in a long time, and we haven't started, and I'm like, oh my God.
I don't think we gotten started yet.
Not really, no.
But okay, so we really want to understand, what the main challenges of getting value from AI is. And I think it's interesting to hear from companies like Epidemic Sound, and that actually have gotten further than most.
Still are humble.
So if we were to speak about to other companies that want to take this journey in as good way as possible, this is a tough question, but is there something you would recommend them to do or not to do to just get faster on the journey to become AI ready?
It's so hard. Right, and it shouldn't be. And when you look at it, how hard can it be? So it's almost dangerously easy to conceptualize it as very trivial. Just get in a good machine learning data scientist person. They do some notebooks as a proof of concept. You just deploy that in paper mill, and then you're done.
Yeah, whatever.
Yeah, so the AI cloud, 10 minutes done. But then like, okay, so we agree this is not it. That's not how it works. But then why is it hard? What are the hurdles? And they are so many and so spread out all over that I don't really know. But for smaller companies, it requires considerable commitment to say, before you actually see before you harvest your first fruit or whatever, you're probably going to spend like 2 years of actual real world time to even get out the first working system. If you're one person doing it, two people doing it, whatever. Because that's been...
But now you're talking about hardcore neural network type stuff.
Or I guess everything really. Because even if you do like decision trees on tabular data, you're still going to be it's still going to be extremely important to monitor the system, make sure it's still working, retraining it. How do you even retrain it? Like, do you just do it? Do you have a version of models?
So bottom line, taking something from a POC, that you flip around to something that is fundamentally useful in production and that is reliable, that have the validity to really be used. Yeah. It's a different ball game.
Yeah, and maybe that's older than machine learning, but A/B testing is relevant still. Knowing that is still the most important question in my work. How do you know that you know what you say you know? Hard. What's in that book? I'm curious.
Yeah, we're sending secret messages.
Secret messages.
No, but I guess one question, at least in my experience that I've seen in a lot of companies, they don't really understand what AI is, and they have a wrong view of what AI is.
That's chapter 1, right? Understanding what it's not.
Yeah, and some people think it's analytics and it's things about building dashboards, which is
last year. We naturally became advanced analytics. Which is fundamentally different, but it's very hard to explain why. But everyone who's worked a little with it knows it's different. And then just having the whole company align around that idea that we have analytics as well, but it's different. That takes time.
I mean, it's interesting to hear that you also had that problem.
Yes, even now, yeah. Not today, actually, but last year.
Yeah, and also in Epidemic Sound that is so forward, but I can certainly resonate with that. Has been one of the toughest challenges for a lot of companies to have the right view of it. And not speaking about the analytical ladder that we spoke about last time, right? Which is confusing people to such a great extent, which is kind of sad. Okay, but AI can be used in various ways, and there are a number of challenges to get that working. Technology, in some way, is there to actually build the model. But would you say also that technology is there to operationalize it, to actually put it in production somehow?
Yes. I mean, obviously, yes. Yes. Making the tools. I mean, why isn't there a Excel or Photoshop for deep learning yet? There should be, obviously. And
but are you saying that the technology is ready for it?
No.
Or no. It sounded like you said it was ready.
But it's surprising why it isn't. I guess it takes time. But when you're looking even at like Google's open source projects, TensorFlow Extended or Kubeflow pipelines,
it's called
which is
AI platform nowadays.
So in AI platform, you have a product called Kubeflow pipelines, which is a 1.0. But it doesn't feel like 1.0. It feels more like it's still in like a beta kind of. You haven't really. It's not API stable. I don't think it's gonna change. It's gonna be a 2.0 soon. And maybe there's some business incentives to get it out. So maybe they got some push on them. To like, no, engineers, you have to 1.0. You want it now. Come on. But when as a consumer of it, as a practitioner of applying machine learning and making it robust, I don't think Google or Facebook, even them, have kind of figured it out.
Right, and that's my feeling.
It's quite far. And partially because of math and theoretical sides of it that we don't really understand, but a lot of it is just like getting the work done. I have a feature list of stuff I need, or I think I need anyway, in a machine learning framework, and I haven't found a single framework that fulfills them.
But could I just ask you? Could you elaborate on the Epidemic Sound stack?
Sure.
Where do you do
There's
your
a lot of
storage?
Kubernetes.
Okay, but so let's start. Let's go the whole way, right? You run in the cloud, right?
Yeah. So everything now is kind of Google Cloud, and then data warehouse is BigQuery, which is great.
And then okay. So let's talk about the stack now. So like go through from the storage, data engineers, and then how do you sort of see the flow, the workflow?
Yeah, that's a constantly changing thing as well, because there's explicitly there's people here doing stuff, and they come in and they leave and they change work, and we have more and less, and but the stack is very GCP oriented, which I think is a good thing. And
why is that?
Google Cloud.
Global Cloud.
So when Google Cloud platform. When you the nice thing about saying vendor lock-in is a problem, but let's not care about vendor lock-in now. It's that you can actually use all of those nice tricks between the products that they offer and not be worried. Like, we put that on the backlog to be not. It's
simpler to be in one universe.
It is, and that's kind of a nice thing. So, like saying like BigQuery pops up in Google Sheets, kind of neat. I'm using that at work for some reporting for fun, and then we use a lot of BigQuery, obviously Google Storage, Feature Store, no idea. Should we use Hopsworks? Maybe. Should we use something? I don't know. And then now it's DVC a lot, which I like. But it's
and where is your sort of modeling environment, and how do you deploy stuff?
So everything is very Kubernetes oriented, which means containers, and that's a great thing. Really, that should have been a default for.
We should have understood that. Imagine all the notebook crap.
Yeah, but I don't mind if you have a notebook in your container.
Yeah.
As long as you have it in a container. So it's like you can do whatever.
Do you see any challenges with actually, managing and orchestrating a Kubernetes cluster?
Yeah. So what happened quite quickly after that was done was that there was a need for a horizontal team that kind of was working on that only.
Yeah.
But that's fine. I think that's okay. It doesn't.
Sometimes I think about Kubernetes as GDPR. The intent is super good. And you really, really want to achieve the intent of GDPR. And for sure, you want to achieve the intent of Kubernetes. But sometimes you question the type of implementation they have done to
No,
try
I
to.
agree. It's definitely, it's still growing, it's still changing. Data scientists shouldn't work with Kubernetes. But if you have a Kubernetes platform by default from your application developer, so they're already using it for Django or whatever, then you're going to be able to use a lot of the tools that are built on top of Kubernetes. And that's where it becomes probably normal soon and powerful. So if we say Kubeflow pipelines, whatever that is, that's running on Argo, and that's running on Kubernetes.
Okay, so where do you draw the distinction of the toolbox of the machine learning engineer and the data ops engineer? So
they are quite similar, right?
Yeah.
They have slightly different interests.
But Kubernetes belongs to whom?
No, so they're just different. Like we also have DevOps, right?
Yes,
If you say data operations or whatever you call it, data engineers. Our data engineers they're using Airflow.
All right.
Which is fine, right? It's battle tested. But and then there's hyped new tools. We should use that instead. There's some Argo weird ETL thing. Yeah, sure, but that's not battle tested. And then, but the Airflow in itself is deployed in Kubernetes, so they still have to manage it, even though it's like managed by Google Cloud with Cloud Composer.
Right. Now, this is going to be fun. Now you have mentioned all these different brands or different open source stuff.
Yeah.
Could you explain your stack with the different core capabilities. So instead of saying Airflow, what does it do? I need a workflow.
Yeah, it's a work scheduler, right? ETL scheduling.
So basically, let's now not use the brands of the open source, but let's talk about the stack. What are the components of your stack? What do they do?
Is the keyword here data lake? Because that's a Google storage bucket.
Yeah,
yes.
Okay, so we have a data storage bucket, data lake.
Yeah.
And then you said Kubernetes. It's the container stuff.
Yeah, so for orchestrating and auto-scaling then any type of server, any type of workload. It could be a machine learning model that predicts stuff.
Yeah, and then you said Airflow. What does Airflow do?
Schedules data pipelines.
Workflow orchestration, stuff like this.
Pretty much.
Okay. And then
we use it to ingest stuff from data source to data source.
Yeah, and then we talked about CI/CD, continuous integration. What do we go here?
That shouldn't be a exotic thing. I hope that should be more like obviously we have that. As like obviously we have a Git repo. Obviously we have CI.
But you'll be surprised.
Yeah,
you'll be surprised how far off we are, and people still think about this as advanced analytics.
If you go into my repos, you're going to see that they don't really have coverage either. But the ambition should be obvious.
So what do you do? What do you do for CI/CD?
Cloud build is good, but now we're gonna go for GitHub Actions because it's such a huge thing. And if that's the default on GitHub, people will learn it in school.
Even though it's a Microsoft thing these days.
Yes, but that's also a thing. Right? So Epidemic has already used a little bit of Azure. Because we like it, kind of. It's
so you have Azure for something and GCP
for CD, right? So some CD stuff is Azure oriented.
Okay. So you're not. Are you worried about mixing clouds or not?
Not if it's very well encapsulated. But there's definitely a little headache in terms of like how they authenticate my G-Cloud command line here.
Yeah.
You have to
and just to unravel CD, I mean, some people think continuous deliveries, others say continuous deployments.
Yeah.
Okay.
What are we talking about here? Deployment? Yeah, good.
Okay.
And what do you use for visualizations? You said BigQuery for warehousing, but how do you use
ongoing discovery?
And what do you give your business users?
Yeah, so that's an ongoing discovery for the analytics organization, which I'm not formally part of, right? I work in tech.
So this is analytics. I really liked how we are really now exemplifying. This is advanced analytics. This is machine learning engineer that we talked about.
Things. But then if we use the same shared language, it would be powerful.
Yes.
So if analytics start using Looker, then I'm going to be interested in using Looker.
So Looker is the visualization tool of GCP, right?
No, it's one of them.
One of them.
There's many. So Data Studio is very good. That's good enough for many. It's lightweighter. Is that a word?
Yeah.
So Data Studio, I'm using Google Sheets, honestly.
Yeah. It has I think we mentioned so many different techniques now. I think it could be nice to try to encapsulate that in what we've been speaking about for a bit right now, and then get back a bit to your passion as well, which is music, and speak a bit about that before we run out of time and
I love
get too drunk from the beers or whatnot. But anyway, so we've been, for one, speaking about how really to accelerate AI in different companies. And there are a number of challenges. One is the techniques behind simply deep learning. And we have a lot of progress there and we can do a lot of stuff. But then there is a number of techniques necessary to actually put it in production and actually get value from it. And there are a number of challenges, right?
Yeah.
If you would agree. Yeah?
Yes.
And then we have the whole competence, understanding, how do we really make machine learning a natural part of epidemic sound, as you said, right? And that's kind of, it's more of an educational journey?
Or? I think that's part of the solution. Yeah. So everyone has to know more. Helps.
And then we have a number of techniques. We have cloud computing and different services there that we can use, and Kubernetes and CI/CDs and whatnot. And if we were to speak to some other company that were I heard all these terms, I don't know what they mean, but I really want to have a good tech stack to make sure that we can really operationalize AI properly. Then is there something, I think you said a number of things you'd like them to do.
Yep.
But can you try to find things that you think this is really a bad thing to do?
Bad things are easy to find, yeah.
Yeah, and okay, well, I'm very eager to say some. But if you were to say some things that you've seen in the past, perhaps from other companies, or something that I wish they simply used, Kubernetes instead, or I wish they used that and that and that. Some bad examples that you've seen in the past. What would that be?
That's in terms of tech stack. It's like if it's stupid but it works, then it's not stupid. So whatever, right? So if you use cron jobs on in a Kubernetes cluster for training models every day, sure. Like you won't have any governance over what came out from where. You won't probably have any artifact history, and you won't find out stuff when it breaks. But if it's working, it's a since the whole software engineering thing for machine learning is still changing a lot.
Let's say a concrete thing. You train your model and put it in production from the Jupyter notebook. Is that a good thing?
I'm okay with it. Yeah, sure. So Papermill is a gamble that I think is interesting. Like I'm not sure.
So explain what Papermill is about.
I guess it's a way of doing exactly that. Like since data scientists use notebooks, then they like it. Let's not force them to learn new stuff. Let them be good at what they are good at. Let's meet them. We are operations. Let's take their notebooks and run them in a not maybe idempotent way, but still in a more operational way where you run them and you get some outputs.
Schedule them and you can have some kind of...
running I'm taking your notebook, I'm running it every day, and you don't have to
similar
port.
to Databricks as well and that type of...
Yeah, probably. I haven't touched Databricks, but notebook-oriented tools that's one gamble people have, right? SageMaker, like we assume they like this tool, but I also could imagine data scientists liking a new tool a lot more than notebooks, because notebooks are hard, and programmers know this. Data scientists don't.
We have Mikael Klingvall and some other guys. They're passionate about using Julia. And
sure, yeah, but
they love Julia because
coming
they can
from
do
computer
everything.
science, I like Julia in many ways, and in many ways not. I've never really used it for anything proper except for playing around. But what they promise is very nice. But it doesn't fundamentally solve my concerns, which is what can you mutate when and why. Why do you have 4 I loops? They don't help me read your stuff. And if Julia is proud of having fast and powerful loops, that's a concern I have, I think. So, but still, Julia is nice.
We should have these guys in the same room, Mikael and Carl, and then battle out.
and I'd like to get into like dependency injection and object orientation, but perhaps we should
that's a good
should we leave the tech conversation a little bit now?
I think it would be fun to make sure that we have proper time to actually speak about music as well.
Yes.
Since I also have a passion for that, even though I think the genre and the type of music we like perhaps sometimes is different, although we like to sing karaoke as well.
Has happened, yes.
Yeah. Anyway,
to forget.
Just to try to set up the question or scenario a bit, it would be fun to hear your view of, AI can be used to help or actually potentially not help music in different ways. It can be for the consumer, can mention recommender systems or whatnot to actually make it possible for users to discover music in a way not possible before. Yeah. And you can think about AI for music for artists as well. So thinking about tools to use to actually produce music and these kind of what was the name of the artist that actually produced the first AI produced album?
Most of them are quite human curated anyway, so it's not that exciting to me.
But they used at least AI in the loop, so to speak.
Yeah, which is nice. But that's been the case for a long time as well. If you think about the normal humanized button on an analog synthesizer, that's AI.
But if we speak about artists to begin with, it would be funny. Do you think AI will, in the long run, be of benefit for artists, or will computer-generated music continue to diminish the need for artists, or will it actually increase the ability for artists to produce music?
No, and the answer could be both, right? Yeah. For certain types of artists, they might have a harder time, and for certain types of artists, they might have an easier time. And the thing is, it doesn't really matter because this will happen anyway. It's like, what will happen? We'll see. I'm not that personally worried about having singer-songwriters not being able to being appreciated, because there's a Python script that makes really good James Taylor covers. I don't think that sounds very far off. And let's say we had that Keras model and it's really, really good. Oh, it sounds so good. It sounds exactly like a new U2 song. I still think humans appreciate the human connections. It still doesn't matter. It's like by definition, it's not as interesting if it is sampled from a generative distribution.
Like someone who has a passion and you can feel his pain. Or
kind of, yeah. So the story behind artists is a very big part of appreciation of music. And if that's the case, then we are fine. It's not going to change much. Exactly in like the same way when people say moving pictures, will books not be relevant? Yeah, they are still relevant. I think it's going to be a very nice complement for, there's two abstraction levels here. First, that it's really important that AI is accessible to everyone, that you can build stuff yourself. It's not. I don't like it being a Silicon Valley thing.
No, that's a real problem actually.
Yeah, it's a little concerning when the compute is so intensive. But having it for everyone, so we can build cool stuff and having a normal thing. I also want everyone to be a good programmer. That's hard, but it's important. democratizing AI. In the same way, you could say like democratizing music production. So if I'm not great at, I don't know, reading sheet music, I'm not classically trained. Today I have software that lets me paint in the notes, and I can be a really good musician. I make many people happy. I make me happy with doing the songs, and I never had to be classically trained. And I don't think this is a bad thing necessarily.
But it's interesting because there's people who have creativity, and I met people who can really, they can feel and hear a song in their head.
Yeah,
but they are not classically trained.
Themselves.
They cannot express it now, but probably with AI they could.
So if we could enable that people that have these nice ideas could express themselves with new tools, I'm all for that. There's no gatekeeping in that. So the obvious example would be to embed some nice auto-regressive predictions in logic, and then I don't mean formal logic, I mean the program logic, the Mac music production software logic. Okay. Sorry, but let's say Ableton Live, something where you record your songs, you make songs. If I have a bass guitar that I just tracked and I want to get a nice drum fill, why do I have to take my mouse and drag and drop MIDI stuff? Can I just like give me a nice drum fill that kind of follows my bass guitar syncopation and it should sound decent? And then I pick and choose the suggestions from the model, but that workflow sounds so obvious to me. And that doesn't take away anything from my musical creativity or my authenticity, because I still chose the whole picture. So like I'm designing it with...
But I think, of course, when it comes to music, Swedish House Mafia, are they proper musicians or are they
basically
DJs?
That's the question, right?
So are they musicians?
I would say yes, but like if you think no, then of course the AI stuff is not musicians either. But that's the thing, right? Why have so many notions about what is true or false in something that's just like if it feels good, it's good. So go nuts.
Yes.
And enhancing that expression with deep learning and machine learning models is an obvious next step for me. That's something we have to do and we will do.
What about simply speeding up the workflow?
Yeah, precisely. Whatever that means. And if you say like, we speed it up for commercial uses, then I'm less interested. I like art for art's sake, but still, whatever. Exploring expression with new tools. How is that problematic? Actually, it's problematic.
What is the problem? you thought of it yourself.
Okay, so like in any type of machine learning stuff that we put into production into the hands of users, we are deeply worried about fairness and bias, right?
Yes.
So maybe we're going to have everything sounding very homogeneous after a couple of decades. But that's already happening with humans anyway, right? So like I'm going to chase the next trend and make a bad copy of the same hit to get on the radio.
But you could see how the music industry or a record label could basically go into a factory style approach.
They already do.
They are already doing it.
Yeah, so that's why I'm not concerned about AI doing that in a worse way. This is hopefully going to be more of a...
they can't be worse than Idol anyway. And AI must be better than Idol.
Business is business, and that has to be solved for any type of AI system. It's going to be a concern for everyone.
What is your thought on Garage Band?
I like it.
Yeah, because that has it feels after you're playing, you can. I don't need to be there. So GarageBand has this logic, right? So you basically play something on 120 beats, and then you get like a choices between different drum sets.
Sounds awesome.
Yeah, right.
Yeah.
So even now in kids, they're my daughter is in school, so they're teaching them how to produce music. It's beautiful. When I was like a kid, that was not possible, right?
Well, GarageBand sounds great. Yeah. You know, like if you play around with that, you get pretty far.
Yeah, and making artistic expression accessible, I have a hard time seeing that as a bad thing.
Yeah.
No. But there are downsides eventually, but we're going to figure them out, I think, because I'm quite technologically optimistic. Fairness and data set bias and all of these huge problems we have, I like to think that we will work around them.
What are the problems you see with fairness and data bias?
There's so many examples, right? But it's like if you go on Twitter this week, you have the cropping algorithm problem that everyone is upset about, and they are rightfully upset. And figuring this out is...
And what is it? Cropping?
If you upload a picture of one black man and the one white man in the same photo, Twitter will tend to crop to the face, but they always tend to crop to the white face. And that's... So the team apparently, they did test such stuff, and it still kind of made it into a big PR disaster this week, and again rightfully so, because it's weird that it does this. You should expect a 50-50, right? It should be sometimes the black guy, sometimes the white guy, whatever. But since so many smart people are thinking so much about these things, I feel quite optimistic about it not being unsolvable.
No.
I mean, I really like what you said about, AI can be a way to democratize music. And I remember one of the quotes from, what was her name? Taron, I think. And she produced this album using things like Amper, and I think she used Magenta, the Google Cloud Library, and things like that. To have basically an album of different songs that contained like all the instruments and her vocals, but she couldn't really play an instrument.
Sure.
But
or the computer counts, maybe?
Sorry?
Does the computer count as a musical instrument?
Well, that's the way she solved it. So she basically said she basically had an outlet, a way to produce music that she couldn't otherwise do because she never learned to play instruments, even though she tried. So it could be seen as a way to democratize production of music, right?
Yeah. So what we said, like you have an expressive idea and you have the music in your head. You have actually something to give to the world. You simply have not acquired the skill of playing an instrument.
Don't want to, couldn't, whatever, many reasons, doesn't really matter. Yeah.
It doesn't matter, but it's ultimately that you have artistic expression, anyway, which is fantastic, which is democratizing in some ways.
Yeah, I have a hard time finding downsides to it, really. And the part of this that I'm most excited about is making it, allowing it to make new expressions, new forms of expression, new genres, whatever. Like if I give you a weird LSTM that's mostly randomly, not even trained, whatever, if I give that to Radiohead, they would probably make a pretty cool song, right? And for me, I want it to be also then sound, so it should actually make sense. This should be a trained model. It should not be just a GAN spitting out random weights. That sucks. But if it's a properly good, reliant machine learning model using someone's new expression, where they make a new cool song, that's
but that's
exciting.
amazing. Think about that angle that you get artists now who are now skilled in these technologies or CNNs.
It could be,
and
next
how
generation
they now take this as the next level of synthesizer. How they, like we did sampling in the 70s, right?
Pretty much, yeah. So this is EDM and working with your MacBook Pro, that's the norm now. Next step might be that you're working with your GPU. You won't see it, of course, because you're not technical in that way, but working with this predictive model that gives you weird MIDI samples, patterns, predicted samples, sampling from Magenta models.
But speaking about the downsides, I mean, now try to really find the downside of this, and imagine a future where generation of music works really, really well, and you can, as a user, say, I like the music I'm hearing, I like the vocals, I like the instrument, but I want to tweak it this way, and you pull some lever, and you get it in the way you want, but it's all computer generated, and there is no real artist behind it or human artist behind it. Do you think that is going to be possible in the future?
For some genres, that's already a quite successful business. But then it's mostly synth pads and quite ambient music. There's never, so like singer-songwriter stuff isn't even on the radar.
Yeah.
But,
so no
ambient music can today really be
you can with an expert system or even with a machine learning predicted stuff, you could make quite nice yoga music that kind of works probably good enough for a yoga studio.
Like elevator music is something.
Pretty much, I guess, and that's fine. It's those type of more ambient kind of not with hooks and lyrics. And let's say we added that you can make nice lyrics and nice hooks, and like this is a really good Taylor Swift impression with this model.
And I know you worked also with the autotune kind of software, and I wish I had access to that when I sing karaoke, because I certainly would need it at some point. But what do you think about artists making use of autotune techniques?
So like if you think like T-Pain, and when it's on purpose, it's an effect, or cheer is the original, I guess. I liked it when I was still, and it's cringy as a sound effect, but who cares? It sounds cool. And then if you do it a little less, so you're cheating then because you're not actually singing in the key. Why? I don't get why people care so much.
No, but I would care. This is a different.
You're using a microphone to amplify your voice
as well.
Yes,
but in the grand scheme of things, you have people who are really skilled, right, and who are real.
Yeah, but I don't listen to music because they are skilled. I listen to it because I like the end product. If it sounds in a good way, so this is the whole picture that matters, and the details are interesting, but they are not the point.
But should we have respect for the virtuosity? Guitar virtuos, right?
Before we get more into it, let's have a more techie kind of discussion about autotune, I think.
Okay.
Since you are an expert in this as well, how does an autotune work, and what does it actually do?
So you're going to enter a little audio signal, and you're going to output another audio signal. Hopefully that sounds extremely similar, except slightly more on pitch, whatever that means. So then you might want an extra input, which is what is the melody then? So we should fit to some melody. And when you do this in a naive way with signal processing, you might accidentally change the vowels that you said. Because if you pitch shift the whole thing, all the frequencies, you're also going to change your formants, which is a hard thing to explain.
Is this when you get that autotune, like sort of cool sound, if you think that's cool?
The chipmunk effect rather, which is not cool, but it's nice.
But sometimes you use autotune.
So the skipping thing, the T-Pain effect, the chair believe in love effect, that's more the speed of which you pitch shifts. So if you hook on immediately when it predicts this pitch and shifts everything, that's a nice skip that people kind of like because it's quite musical.
And how do you build an autotuner?
You don't need machine learning to do it, right? So that's the thing. You know which frequency you want. If you did that and you just kind of move around stuff in the signal, let's say you had a spectrogram. I want to translate a little. I want the big activation here to be up there. You can do that manually. If you do it with machine learning, you get state-of-the-art results, but I don't know if it's necessary.
Yeah, still get a...
But when you look at Antares or the other one, I forget, they have used some form of energy-based minimization thing. But I think...
But traditional signal processing techniques works rather well.
Quite well. For monophonic, like if it's a single vocalist, if you give me a choir of many people and all of them sing a little out of tune and they're mixed together, then I'm going to go, deep learning might be better here. I don't know even how to start. And end-to-end learning, that could be kind of cool. And I think that's an active research topic. Like how do you tune a choir? That's where deep learning is.
Just like
I have a question.
Yeah.
So you're often saying this, and you seem to agree on this, right? So how do you know when to apply deep learning or machine learning, or this is basically an AI problem, this is not an AI problem? Because it's fantastic, but I don't get it how you know, right?
So I tried to distill that into we have a tech onboarding, and in those slides, when you start as a software developer at Epidemic Sound, you get onboarding from different people. One of them is from the machine learning people. And in those, we have a couple of slides about how do we know that, like what type of projects are suitable for AI techniques and which ones are not.
This is a key topic for the general
and I think
application.
So what's annoying is that to learn that rule, you have to kind of go by some examples. That's almost easiest. Because if I gave you my rule of thumb that I'm using, I don't think it would make sense without examples.
Try.
But it's going to be, if you're thinking, we said self-supervision, right? So for me, it's going to be, you have to be able to do early stopping. It has to be discriminative, otherwise I can't sleep. And then it's going to be self-supervised as annotations, which makes no sense. But fundamentally, you want, for each individual input to my program, I have to know a corresponding output for that particular input that I want to have. And if I can't say what I want to have, then we don't have much to do with machine learning, really. We could do clustering, we can do those things, but we can't really do deep learning in the sense that people talk about it. So you have to have a bunch of, let's say, 10,000 inputs, and you have to know which output each of these should have. And if you give me that list, an Excel sheet, then I can do it with machine learning.
So how does your AI canvas look like that you take into the business guys when you start sitting down and trying to translate the business problem into qualifying if this is a machine learning problem?
So that's a two-way street now for me. It's going to be, I can't explain this in a good way, and people won't be able to go around and look at different types of data pipelines and determine, this is ripe for TensorFlow and this is not.
How do you do it?
Exactly. How do I do it? I think they have to, everyone, all of these business people, they have to kind of go through, let's say, elements of AI. They have to do something. They have to get kind of their own grasp of what type of data do these people
What is
about.
elements of AI?
So that's an online course that's kind of for business-oriented people about what is machine learning really? What's
to learn the basics of AI, basically.
Yeah.
I took it recently, and one of the questions was basically how to determine if this is a machine learning or deep learning project, and that is basic problem, and that's why I wanted to ask you, because I think this is very important, and many companies are like, yeah, let's do AI and machine learning and deep learning, but actually maybe that project or problem is not something.
Yeah, I mean, if you give you my rules, you won't be able to apply them because they have so many weird math terms, so it doesn't help. So you need to see examples.
Take the vocodine, right? Or what was it? The melody that you're using.
Why doesn't autotune need machine learning?
Autotune and etc. Okay, is that a machine learning problem?
So these days it is, and it's been for a while.
Why?
But if you want the highest quality, but if you want a good enough model, you don't need machine learning. And that's also a thing that machine learning practitioners and business people forget. Choosing a strong baseline. What's the current best approach? Probably deep learning. What's a good baseline that you can run on a Raspberry Pi?
For a tenth of the cost.
Yeah, it costs nothing to do. It's quite cheap. You can pip install it. What's that baseline? And we tend to forget that one. And so having that first, and that's where for auto-tuning we go like, you can get quite far without machine learning. And then if my business stakeholder says, but it has to be even better, that's where we go, okay, so maybe we need data-driven approaches.
But this tells you a lot about getting started with AI. Starts with, I mean, like this whole journey of adopting AI, it really starts in the beginning where how do I have people who can translate business questions into data and analytics questions and understanding the right fit of what what type of analytics we need. This needs to be a core competence.
Yeah, but the core thing has to be that everyone, not the technical AI people or the data scientists.
They need to be savvy enough.
Everyone has to be kind of, a little like they have to have data literacy. That's very good. That's very helpful. It's easier to talk then. But primarily, we have to, why do we need a baseline? What's a baseline? This is just experiment design. How do I know that this system is worthwhile building when I measure stuff? Why do I measure stuff? What conclusions do I draw from my measurements? That kind of essential scientific practicing stuff, that is even more important for business people. So they can go with the counter question of like, okay, so you made this cool Keras model. What's your baseline? I would love to hear that from a CFO.
That would be cool when your CEO.
How do you measure? What's your metrics?
What's your baseline?
What are you measuring?
Yeah, when that becomes like the normal type of terminology and type of
when
communication.
When that becomes a CEO
terminology,
what's your baseline for this algorithm?
A fun future to have for sure.
And then it's also easy to get too hung up on baselines because every model is wrong, and that includes metrics. Metrics are proxies, but they are very important to know about.
Yeah. Would you say, thinking about, when to use machine learning or deep learning or not, I guess, one basic rule to have, if you agree, is like Occam's razor. Okay, not true.
Let's go here.
But okay, so Occam's razor basically says, if you have like a number of choices to make, please choose the simplest solution possible that is satisfyingly, performing well.
If you are performing exactly the same, pick the simpler.
Not exactly the same, I would say, but
because then we're in the real world.
Okay, but let's reframe it. There is an extra, like, inherent value in simple solutions.
Yeah, no. I think when
really?
Yes, if you knew that this is simpler, yes, but there's uncertainty in your estimate of these models. You can say this one is simpler than this model. Okay, how do you know that?
Okay, but let's if we take some concrete examples then and speak about simplicity in those. So we can say that, okay, let's do autotuner. We can build it using manual programming and building up the rules, and you use the spectrograms, and you can manually program without using any data at all, saying this is how you build an autotuner.
Great example.
It's a simple thing to do, and you just manually have to program the rules.
You could do it data-driven as well, I guess.
Yeah, so that's the next step then. So if it becomes too, underperforming or not really good, working that well, perhaps you need to use data instead to learn, how to really make it, predict the right things.
Might make it simpler, I would say.
Well, it would add the requirement of data to it.
That's one requirement, but it will also maybe remove the requirement of domain expertise.
Of the human.
So then you're going to go like, which one is simpler? The one that doesn't need smart people or the one that needs data? And I guess that depends on your practical particular case. If you have data, maybe it's easier to just do deep learning.
And if you have domain experts, you can also make use of them sometimes. But
yeah,
if you
so
don't,
the hybrid approaches will probably always be the way forward if you really want to cream out the last couple of decimals on your accuracy. If you want to make the best model, then I think you need both. But if you have, what's simple there?
Yeah, I like actually that kind of thinking. Simple can be different things.
It really depends on the context.
I think if I'm leaving after a notebook with NumPy code where I wrote a lot of like Fourier transform kind of smoothing things to predict the pitch and shift around stuff, and I give it to someone, I would be more comfortable giving a Keras notebook because I think more people will learn and know that stuff than the signal processing stuff. So it really depends. Which is a cop-out answer, but yes,
it is. But still, if we ignore the definition of simplicity for once and just think about the general concept of the more simpler solution you can build, the better one it would be.
Why? If it works the same, why do I care?
Because it's easy to maintain. Is it build?
Okay. So if something is
build,
easier to maintain, then I would prefer that. Yes, if they work the same for the end user.
So the definition of simple is not straightforward always.
No, probably not, right? And that's why I think when people use Occam's razor for machine learning stuff, still, it might turn out that deep learning theory is too new, and we're gonna in 10 years, people might say like, oh, this one is so simple. It's first order derivatives. You minimize something. And it's this is the simple one. And the whole other side of it, where you have feature engineering and you pick features and then you do SVMs and all of that. That could feel in a couple of years could feel very complicated. Why do I need to know about edge detectors? I have images.
That's a really good comment, I think. And thinking about the horrible kind of feature engineering work that I did, my early years before deep learning really became popular.
It's a waste of time almost. It's nice. It's fun.
It's a lot of work and it's a lot of manual programming. And if you can avoid it, it can really make things easier and actually more efficient as well, or more performant as well.
So let's talk a little bit about feature engineering and the buzzword of 2020 Data Innovation Summit, feature stores.
Feature store is a different thing, right? That's caching outputs for different downstream training jobs, and that's good. If you call it feature store or data lake.
So what is it in layman's term?
Feature store. I guess you should ask Dowling about that because it's not a term for everyone. But to me, it's been like if I'm going to train a genre classifier in one part of Epidemic Sound, that's a little Python script. Then I'm also going to train a mood classifier in another part of our code base, and it's quite big. Do both of them have to go back to the raw audio to do all of that stuff? Okay. Or could I just use a versioned data set of the spectrograms? Yeah. And where do I find that data set? Where do we put it? In a feature store, I guess. And that's probably very useful in terms of scaling if you have many people and many different tasks. But what I'm currently doing is just have a joint task training thing with the same, both objectives in the same loss and whatever. Like then I don't have to think about it.
But I think this is quite big and also a huge misconception here. Like, so when you start doing not only the vertical scaling but the horizontal scaling, I think this is also the main misconception about a data lake. And then we build a data catalog or whatever we talk about. And people seem to think we need to catalog our raw data. No. Now we talk about you have assets in so many different dimensions. And this is, to me, I think it hits home.
Enriched data goes into the feature store.
Yeah. So and we've been talking about data flow assets, analytical asset, BI, visualization assets.
All of them could use feature stores in terms of enriched data sets. Yeah. And that could be a nice denormalized table where you don't have to join a bunch of weird stuff. That's a feature store.
Because we get into a whole, one of my passions is really has to be to talk about these topics, data and analytics algorithms as an asset, right? And you get into the whole idea of, what is data management or data stewardship, and where I think that kind of the whole idea got hijacked by GDPR and the governance from a policy point of view, where it's actually
GDPR is a good thing usually.
Yeah. But what I'm saying is that when you get into a huge company now, when we talk about we need data stewards, or we need someone to take care of this, it's sort of data protection officers sort of hijacked the whole data management, data governance topic, where I think ultimately how we classify, how we have our metadata, how we have our libraries, how we have our feature stores. There's a lot of work going into here to find it, to search
very
it.
similar to software engineering.
Yeah,
where
of
you go
course.
like, should we build a library for this? Should we not? We have 3 repos using it. Is that too many or is that too few? Kind of similar things.
It's absolutely similar things.
Do I want to commit to having these spectrograms out and version controlled for my colleagues? Do I want to have that? Then that comes with a maybe maintenance cost.
Yes.
Usually. And is that worth it? And could we make it less expensive with a nice framework? And we call this feature store. Then I like it. That's going to change my conclusion.
But it's the classical, quick and dirty to get value out now.
Yeah.
How does compared to
So
scaling,
the world
right?
is quick and dirty for me anyway. It's going to be, let's go to the raw data, just rerun the thing, because that costs 1,000 crowns, whatever. Thinking about it costs 10,000 crowns. So whatever, let's just go.
But then you have the feature stores that you have in your head or in your own library.
They live on Slack.
Yeah, boom. And then you have in the team, in the tribe, and then to take this enterprise, right?
Yeah. So maybe the goal is not to know how to do it. It's do the appropriate thing for your current scale. So once Epidemic Sound has more machine learning models out in production, and we notice that they all share the data pipelines, then we will be more interested in saying, feature store might actually be worth it.
So
should we have an infrastructure, a machine learning infrastructure team? Because I know Spotify they have that. They're on the scale where they have not machine learning people doing products. They have a machine learning infrastructure team. And that's a very normal thing, I guess, when you got to that size.
But that's the whole point, right? That data and AI ready is a constant journey in relation to where are you right now in your maturity, and and the first maturity will always be, in my opinion, just get to vertical production.
Probably
from
to show some early value anyway.
Insight does value, but now I put it in production. Okay, do I have a problem when I have 2 pipelines? Probably not.
Yeah.
Do I have a problem when I have 10 pipelines? Not really. 100?
Yeah, it's going.
100?
Yeah, it's and then maybe people are worried that it's too late, but I'm still gonna think like it's premature optimization. That's really hard. Ask me again in like 2 years, and I'm gonna have a different story.
Yeah, because you will know by.
Yeah, once we have more products out that are all driven by different APIs.
I told you so. I wished I had.
Yeah, might be. But while I'm maturing my thinking, the frameworks are also maturing.
Yes.
And I like, let's say once a month anyway, I sit at home, drink a little wine, and get tipsy, and like look at Kubeflow. What's the state of Kubeflow? Not great yet. Okay, never mind. Let's look at MLflow.
Right.
Yeah, there's so many different projects that promise to handle or help me with the machine learning model lifecycle, retraining it, A/B testing new ones. I have a new candidate best model. Should it go out? Let's try it on a subset of users.
But how far are you guys into the product category of data intelligence? I mean, like you have technologies like Colibra, who basically are now investing quite a lot in AI to basically apply AI techniques to basically identify these libraries, identify the similarities. So basically,
sounds hard.
Well, like all the stuff here is the problem with all this is like someone needs to annotate, someone needs to do the metadata, someone needs to do the description of the library, and to keep the library, as you say, is costly or it creates headache, right? So why won't we have AI who helps us even identify similar code patterns?
The more higher order you go, the more cursor dimensionality you get, and the less. I mean, eventually, yes, definitely, gonna be a thing.
But it's not eventually.
I mean, work in 2020 with stuff. It's gonna be quite end to end. You go into the raw data lake almost, and you're like, let's run data flow, make it into nice TF records. Let's train on that. Let's schedule this in Kubernetes is good enough. Whatever. Do we need a pipeline? Yeah, maybe 2021. I mean, we're going to grow with that. And the nice thing about not doing it too early is that all of the frameworks that you're offered, they're also maturing.
Yes.
So I don't want to commit to Kubeflow pipelines just yet. And if I do it later, I think I'm going to have a nicer time.
It's a little bit like, do I commit to Beto VHS?
Kind of, yes. You don't want to be the first adopter of a DVD player because they cost a lot. And when you look back at it, it's like 480p. That's garbage.
Yeah.
Hard to say.
So you're saying this whole field is really evolving super fast right now?
Yeah. I mean, this is yes. as a engineering discipline.
Cool. I think that the time is really flying by here, and I'd like to get in some more topics as well. We've spoken a lot about like trying to operationalize AI and all the problems you have with, moving from a prototype into some kind of operationalized
Can we do it like
version.
this? Just to name this, I think that we are about on a 150, so we're talking about almost 2 hours. So the next 20-30 minutes, we speak 10 minutes on a specific topic.
Right. But why don't you moderate us a little bit? Then?
I don't moderate it. You moderate it.
But you become the clock then.
I become the clock, the timeout, and etc. Right.
I like it.
So we have
Let's
a
try
topic
this.
and we run. Okay.
Okay. Good.
Okay, so let's try to move into a new topic then. And you spoke a bit about intelligence, what that really is. And you spoke also about 10 years, you may be able to generate music in a way that is actually very, well-sounding. What's your view on, for one, how would you define intelligence?
Yes. That's a fun one.
And, moving that then to 10 years down the line, so to speak.
Yeah, so I have no idea. Really, I really don't know. It's a word. I don't know how I define that word. How would how would you define it?
No, but I can speak about other people defining it.
Yeah.
The Mr. Keras.
That's a good one. Yeah.
Yeah. So in short, he basically says that intelligence is skill acquiring efficiency measure. So the ability to quickly acquire a new skill, if that is playing a piano or singing a song or driving a car or whatever, doesn't matter. It's not about the knowledge of how to do things. It's about the ability to efficiently acquire a skill, the knowledge.
I like that. That's being smart, right? Being quickly adaptable. That's nice. But that also maybe diminishes the value of knowledge. So because if you have a 60-year-old professor in a room and they are very knowledgeable, they would also probably be perceived as intelligent quite a lot.
So but should you use the term? I mean,
it's distinguishing the two, right? Both are valuable, but
exactly.
I guess the whole idea is to distinguish this intelligence and there is knowledge.
All right, so
both
if you want to contrast intelligence to knowledge, then I will agree. How quickly do you pick up patterns? IQ test, right?
Yeah, that's perhaps not the best example. But
No. But it's based on the premise of it doesn't revolve around knowledge, and then in practice it does because you can practice it. But
and then of course let's throw
abstract.
Let's throw in the word EQ, right? Intelligence.
Sure. How are you emotionally intelligent?
Exactly. Okay.
It's hard. And intelligence. If I worked with React, React Native, and I'm an app developer, and I do Android and iPhone apps, and I've done that for a couple of years, I wonder what they have as a side topic that they talk about all the time. Because when you work with machine learning, it's always but what is intelligence? How does the brain work? I wonder if web developers have the same thing about something else. So how does flowers smell?
No, what is UX?
What is UX? What is experience?
What is experience?
And if they have those kind of high-level thoughts. And
I love it. What is experience?
I don't know. But I don't want to...
That's the same philosophical idea in this world, I promise.
Kind of. It's very philosophical.
What is experience?
And I love philosophy.
What is a good experience?
No, but philosophy is fantastic. I love it. I love especially the scientific philosophy of what is science, what's a pseudoscience, all of those things. Extremely exciting. I was almost going I'm going to study this for 3 years because I just want to go all into it. But it's a different thinking hat. Yeah,
what is science?
That's an open question, I think. But but having this thinking hat, in this context, I'm an engineer. Here I'm building stuff. That means I abstract away certain uncertainties, such as what is intelligence? I'm putting that on the Jira backlog.
Yeah, and the interesting thing is now in our interview, in our conversation with Mikael Klingvall, I'm not an engineer, I'm a scientist. And we talked about general science, applied science and all that. And I think you're similar. You're
applied science.
No, but so the point is that you are proud in two different roles.
Yeah, both
and they are both very valuable.
Yes, and it's nice to have the long-term thinking.
So it was also a key point that Mikael made that sometimes it feels like I'm making myself out of a job because they thought they wanted an engineer. I'm a scientist, and this is what I'm good at.
The most admirable people I see is those that are both.
Yes,
and that's very cool. It's very rare, but someone who's really, really good at measuring stuff and doesn't diminish it as beneath them, but they're still very forward thinking and can actually commit to making the full thing. So it's very not to be rude, but I'm sick of hearing theoretical people saying theoretical stuff and never committing to actually seeing if it works.
Yes.
Cool. So it's so like when you look at some people, it's like, whoa, they actually fulfilled and they thought something, they tried it, whoa. And like, I don't know, personal favorite, whatever. I like Jeffrey Hinton a lot.
Who is he?
He's a deep learning, early deep learning person.
One of the 3 pioneers or deep
So
learning.
who are the
mafia
3
people.
pioneers?
So those are, I guess they are Joshua Bengio and Jan LeCun and Jeffrey Hinton. But that's sometimes people get upset when you say that because it's also like US versus Russia, maybe it depends.
Canada, it's okay.
They are in Canada, yeah, but it's Western versus Eastern.
Yeah.
But still, Jeffrey Hinton is very admirable in terms of like committing to his idea and going like, I think this should work, and he tried it a lot
Until
works
it worked.
hard to actually.
and many ideas didn't, and that's fine. And just like someone who's forward thinking and also engineering enough to make it show result.
Super
That's
cool.
the goal. I don't really care about thinking forward because that's easy. Ideas are kind of cheap. Good ideas are cheap.
Okay, so some.
Can I have a next one now? I want to have a topic now.
Okay.
Oh yeah, we didn't even have a topic.
Okay, boom, new topic.
Intelligence was
5 minutes.
trying
That's
to.
enough.
I never answered the question.
Boom,
by the way.
2 minutes. Let's go faster. Let's go faster. Boom.
Okay.
Okay. What's the news word stuff of you or Epidemic Sound?
Yeah, that's gonna be cut. I cannot. But basically, we're gonna do more personalized recommendations. But that sounds so boring. But it's gonna be cooler than it sounds. But it's like music people; they don't care about programming. They couldn't care less.
How
They
do you
should
build
just work.
how do you build a recommender system?
Collaborative filtering.
And what type of techniques are you planning?
So
to
we have context-based collaborative filtering models out already, and they're used.
Content-based are using or looking at what type of data?
Content would be then listening to the audio for me, but it could also be looking at the metadata of the items. But for me, it would be actually going very end to end.
Yeah.
And that's something that we're actively working on out of this year. I think we're going to have a nice little deployment of some form of music similarity search, where hopefully it works as it should. The hard part about those machine learning problems and projects is how do you know if it works? You don't have an accuracy. You have a listening test, and they are not particularly fast. You can't run them in Python.
You recently changed your logo.
Yeah.
Why did you do that? Do you know that?
I know.
What was the storyline internally in the company?
I mean, I know the story of it. I think it's not my field, so I don't have many opinions about it. Like, I would be concerned if the head of brand comes in and says, "This is AI," and he would probably think I'm a weirdo for saying, "What this is a brand." I don't even know what a brand means. But the idea was that naturally over time, the previous brand wasn't really an identity. It was more like a spread out, organically grown, different identities, kind of aligned, not really on purpose aligned. And the rebrand then would be an attempt of making it unified and having a one identity.
Very cool.
But this is kind of corporate speech. So, I mean, for me, it felt like, can't you just spend this budget on buying more GPUs, please? I'm gonna run stuff. But that's arrogant, I know.
Yeah.
And it's probably useful. But it's shown some early promise and also some early detraction, right? Because people don't like a new brand. When Gmail changed their CSS, I got upset.
Yeah.
But I don't even remember how it looked before.
Exactly.
So change is kind of.
And what is new in your life, or where are you at right now?
RTX 3090. Let's go.
What's that?
It's a graphics card. Let's buy it. Let's
Let's
order
buy
it.
it.
It's not available in Sweden yet.
No,
right?
not yet. Not yet.
How do you get your hands on it?
Who knows? Who knows? There's supposedly only one 3080. That's the current meme anyway. That's the one that Jensen held in the presentation.
Really? Oh.
How many do they have?
One.
But making deep learning a normal part of programming.
Yeah.
I think it's going to be a normal paradigm. And I would love to see it being like part of compiler infrastructure, but also part of end user in programming, the language.
Now, speaking about programming and making machine learning a natural part of that, I mean, there are a number of ways to do that.
Yeah.
Python is the go-to kind of language right now.
Yeah.
And
I saw the smirk.
Yeah. No, it's
I mean, it's unquestionably like the number one language right now.
Yeah.
But then you have Julia, and you have like Swift for TensorFlow, and you have this kind of
more exciting.
And you have this kind of differential programming language as well coming up. Anything that you are especially like hopeful for?
Particularly that one. So that I've never talked to him or don't even know him. But Mike McInnes, or what it's called, Mike Innes maybe, at the Julia project with the Zygote. So having derivatives all the way up in the compiler and in the whole programming language, that sounds extremely powerful to me. Like that sounds like I think when we look back at this period, 2020, in a couple of years, maybe 5, maybe 10, they're gonna go like, whoa, they didn't have this as a language before now. Like how did they do it? Yeah, they had a DSL. It was called TensorFlow. It's super hard to learn. Like I think it will be very normal to say, give me the slope of my thing. And my thing here is a symbolic thing using English words. It's called Python 2, whatever.
So is Python so dominant now? So it's already
Python's gonna stick around, but then it's also gonna adapt. But all of those initiatives, I don't even think Swift for TensorFlow people think it's gonna be the solution. They just explore the UX. How would this work for the next language? So it's gonna this is first generation. But having so gradient descent with backprop is surprisingly powerful for many stupid things, and it still gives great results. Way more than people would have thought it would have been. Like, is it a min or max? Whatever, it tends to be a minimum, I guess. And like all of these stupid things, it turns out empirically that it's quite true. It's very powerful to use. Let's promote this to be a first-class citizen in a programming language. I want a little nabla, or whatever.
What?
The gradients, taking the gradient, the symbol. But all of these mathy things, they should be a normal structure. Like you have a list, you also have a autograd engine, because that's very normal to use when you have a web server. How many workers do you need for your current requests? I don't know, let's do a little optimization here.
Just take the derivative of
something, the change of the thing, and like let me follow that, and maybe that's called signal processing, maybe it's gonna not be called machine learning, but having gradients in languages would be normal, I hope. Even though now currently it's quite uncertain how it will feel, and it's going to require new courses at KTH.
Oof, tough.
But still.
Who are going to give those?
I don't know. No. I don't know.
No. Perhaps Carl?
Carl.
No, but differentiable programming is cool. Bridging the gap from numerical computing and machine learning. And sharing tools. Very nice.
Good one. I almost wish we could speak more about software engineering and
programming.
We're
going to do it on another place.
Yeah, we could do it later today, perhaps.
Yes.
So
at the karaoke bar. At the karaoke bar, I assume.
And I love to have the discussion about the dependency injection versus object orientation and these kind of things. But I don't think we have a time right now to do it.
So one more topic at least. One more topic.
Can I choose? Or
yes.
Should you?
No. I did mine. Now it's yours.
Okay. Which one should? Okay. So let's take. You spoke about singularity a bit, about what will happen in 10 years, and we have people like Ray Kurzweil that says basically in 2029 we will have a singularity, and basically saying that
maybe
the AI will be better than humans in basically any kind of task. What's your thought on that? Do you think for one it will happen? Do you think it will be a positive or negative change in the future?
I mean, if you ask me tomorrow and the day after and the day after that, I'm going to give you the opposite answer based on my mood, because it's a very hard question. I think it's probably a bad thing, actually.
And why is that?
I don't see... I mean, it depends on what we mean by singularity. If we mean a machine learning model that starts to learn its own tasks and starts to design tasks that it needs, and it bootstraps some form of like, now I'm doing this all of a sudden, and it's out of the control of me. First of all, it sounds... terribly philosophical. Like I don't even picture how that could work in practice. There's no mechanical way of it happening that I know of. But if it happened magically, like my Keras script is now a new Keras script. Now there's 10 modules. What? Now it's minimizing what? This is GPT-4 all of a sudden. All right then, and just kind of spawns off, and my machine is now taking over the world, and it's a botnet. That sounds like a bad thing. And if that's what we mean about singularity, like it's outgrowing us faster than we can keep up.
But do you think there is like a time point where it unquestionably be, smarter than humans?
In all tasks.
Any task,
because there are tasks where they are.
Yeah, of course. But okay, all tasks. Better. Okay, I understand what you mean. All tasks, or like say a majority of the tasks. Then,
what?
Like compared to an average human, they will be able to do things in a better way.
Yeah, could be a good thing. If it's your friend or if it's your enemy, I guess it depends. It's so philosophical.
I heard once Sam Harris speak about this recently.
He's very negative, right? I think.
He's concerned.
Yeah.
But if we don't do it in the right way, he basically says, he basically, same as Ray Kurzweil and other people, believe in the exponential kind of development. Like Moore's law, it's exponential, and basically intelligence, he says, is also exponential. So although we have been working with it since 1950s, it's been going really, really slow, but suddenly it starts to accelerate now. And if we just extrapolate that curve in an exponential way, it will basically happen in 2029, according to Kurzweil. But still,
maybe, I don't know. Let's see. That's soon, so we'll see.
It's soon.
That's something we will experience.
Yeah, exactly.
But the example that Sam gave, if I remember it correctly, was basically saying, imagine you have a computer that is exponentially more faster, perhaps not intelligent, just faster. It probably is also much more intelligent, but ignore that for now. Just think, downplay it a lot and say, it's just 1,000 times faster than you. And then you're sitting and we are having a discussion, and I'm an AI right now, and you ask a question to me and I'm supposed to give you an answer. For you, you have like perhaps 2 seconds to think about what the answer should be. But for me, I am 1,000 or 10,000 times faster, so I can have a year to think about what my answer should be.
Yeah.
And if that were the case, I have a year to answer, think about what I should answer to every question you ask me. I can give some really good answers.
Yeah. No, so meta learning is cool, and meta learning is cooler. But what empirical results do we have that leads us to think about this at all?
Well, if you just follow the exponential trend we've seen so far, it seems to be exponentially growing.
Yeah, right? But then I'm sure statisticians have many fun examples of exponential trends that actually then all of a sudden have something else because there's some underlying latent constraints, something like there's stuff.
Who knows?
I don't know. It's interesting. I work with pattern recognition, not reasoning.
Yeah.
So I don't know.
But what do you think that the negative? You said it potentially is going to be negative.
Yeah, if the optimization that this thing tries to minimize doesn't align with what I want it to, I would be a little concerned. Yeah. And how do I know what it's minimizing if they all of a sudden make their own objectives? So I'm just, I hope they like me, I guess. That's fine. But it's also, I guess, for most people, it's not vastly different from the current world, right? So,
how many people are you aligned with today?
Aligned with?
I mean, it's usually called the alignment problem. This, AI in humans. So if AI continues to grow,
so if they want what I want, then we're happy, right? But how many humans are already? Yeah, not
so
many, I guess, but more or less. It depends where you are. How many people are aligned with you, would you say?
No, not a lot.
But more than, How many people of those have then access to nuclear arsenals? That's maybe more the concern.
These are tough questions for sure.
I need to throw one more question in now. So how do you feel about the whole discussion around explainable AI, or we need to fundamentally...
Super important. Yeah.
We need to understand what is happening, and no one understands what's happening in the black box. And I think a lot of these speeches are done by people who doesn't really know how the neural network works.
Yeah. So the black box is very transparent. It's like, it's just that I don't like the explanation, but like here is the explanation. Here are all the activations.
Yeah. So
that's an explanation.
So let's debunk the myth here a little bit, because I think there is some real misconceptions.
It's not a black box because you don't understand its explanation, right? That doesn't make it a black box. That just makes you not smart enough to understand the explanation.
Could you elaborate on that further? Because this is
what we need is tools. So we need tools where the goal of the tool is to have the explanation feel satisfactory and understandable to me. And I don't know how I think, so I can't really script myself even. If you look at a neural network and you're running a forward pass and you get out some prediction, what's opaque about it? The numbers are there. You got this number, you got this number, you got this number, you got this number. You even have some prior knowledge about how these numbers were set, because you actually probably trained it with gradient descent. So you know a lot of it. You know exactly which training data it had, and you know exactly how it minimized the thing, because you did that. But so then go like, this is a black box because I don't understand these numbers. Yeah, not a black box then. Then it's more like you're not happy with the results. You want to condense them even further. And that's valuable and important. Having easily interpretable explanations, I guess, is the key. But explanations we have. And then you have tricks for this, like, which one's pointed to this class, which is the steepest gradient here.
So what's the problem here, really? Because the problem here is a little bit like
humans.
Humans are the problem, who are not super experts to understand what actually the CNN has done. And in the end now,
It goes both ways, because we want systems that we trust, and to trust them we need to understand them.
Yeah.
But they are not opaque, the ones we have. It's just that we don't like parsing an explanation that is consisting of 100 different random floats. That's not a good explanation.
But this to me is all the way boils down to a new paradigm in how we organize and how we manage. So a Tayloristic type management. I'm the boss, so I need to know better than my people in my staff and decide line manager towards them. And here we now have a new paradigm, which is a collaborative paradigm with the cross-functional teams.
Sure.
And my responsibility is to manage the bucks or the money or the marketing. And within my team, I now need to trust someone to be the data scientist or the machine learning engineer. And I think that's the real paradigm here, that it's a new type of leadership needed and a new type of understanding of this. So the problem is you're trying to apply Tayloristic leadership, which is sort of implying that I'm the CEO, so I should know best. And I don't have a fucking clue around this topic.
That's kind of the core of it.
I think that's the core.
I think it's interesting that we should put very high standards to our programs. We should.
Of course.
Because they can have dangerous impacts otherwise.
But you can never expect the CEO to be
Maybe we
data
should too, but we don't dare to, because we're all humans. But it's interesting to me that, like, okay, so the thing we had before, you had a neural network that had forward passes with activations, and that's, at least it's transparent. You can look at the numbers. These are the numbers that make this classification. That's it. It's deterministic. Before that, we had humans doing it, and if you ask them, like, okay, so what I don't know, what synapses did activate in your mind, or how did you think about it? Usually probably you get...
How was that better?
Yeah, I don't know if that's better. It feels like we put slightly lower standards on humans than we do on programs, and we should put high standards on the programs, definitely. We should also maybe put high standards on everything. But since we don't really know how we think, why do we expect programmers to figure out...
Hippo decisioning be better than machine learning?
Yeah, it's hard.
Tough questions, for sure. I see the time is now over 2 hours. We should try to wrap up.
Maybe a new record, is it?
Sorry.
No, it's not.
Yeah, it was 2:30.
2:30.
Oh, let's go for the record.
No.
You like to break records.
Give me beer.
Okay, Carl, what's happening next in your life?
Music similarity is very important, very cool. It's going to be a thing. I think you're going to see it on a website and go like,
and
nice.
How are you going to measure similarity from a technical point of view?
Humans.
Come in.
I think actually my current best thinking, unfortunately, involves listening tests. That's always the most expensive.
As an annotation that actually will train some model?
Yeah, no, for making nice test sets, I think. And then we're going to have heuristics.
Really?
Yeah, and the heuristics, since they are uncertain, I still want humans.
But similarity based still on the content, right? Or
yes, but like a good heuristic would be if the similar songs have similar metadata, maybe that's good. You could do like average precision on being in the same genres.
Yeah.
You could do these types of heuristics to rank your models, and then you send out your best candidates to humans. And who knows?
And what's the real business application or value?
So YouTubers want to find something, they don't like exactly this, but kind of this. Give me something that sounds like this, right? That's a very normal, obvious thing. Yeah.
Simple.
And like, it's driven by AI. Who cares? I don't want that to be branded. I don't want that to be seen. When machine learning is the coolest, it's when it's just normal.
It's a natural thing.
Yeah, it's a normal
natural.
part.
I want to do something, and it magically got me to what I wanted to have.
Yeah,
Super cool.
I guess the last question is basically, who would you like to listen to on this podcast?
You and Bob Sturm.
Yeah.
And then Jeffrey Hinton, of course.
Of course, that's next on the list.
He doesn't travel, I heard, but maybe remotely. No, but there's so many interesting people, super smart, cool, so many at KTH. And also, if you're going to go to verticals, you should go at Karolinska and KMH, right?
Yeah.
If it's Stockholm based.
Yeah.
And machine learning is becoming more normal in their work as well.
Yeah, I mean, it seems to be really catching on in any kind of domain.
Now I only went for academic suggestions, but that's...
Awesome.
Fantastic. Really cool. A little bit more geeky today, but I loved it.
I'm against that word, but all right.
Sorry, no, I'm gonna take the position here, like in our position here,
But my goal is that you are gonna go on to Kaggle and you're gonna win competitions.
That's all right.
AI should be for everyone. That includes all of us, right? So just build cool models.
Cool.
Apply intuition.
And I'm actually looking forward to the continued discussion after this podcast as well.
By the way, there is one huge topic that we will have after the camera is turned off.
Okay.
And that is going to be about how we're going to teach our kids and how are we going to do the education system to have what you said. Everybody needs to program.
Yeah.
It's also about who's going to win the karaoke contest.
Yeah, that's more important.
That's maybe the most important question.
Yes.
Cool. Thank you very much, Carl Thomé. It is a pleasure as always.
Thank you so much.
Awesome time.
I think we managed to cover the majority of the topics, which I didn't think we would be, but everything from what is really who are Carl Thomé, who is Epidemic Sound, how are they continuing to use AI in Epidemic Sound and the challenges that do exist, AI for music, philosophy, and so much more. So
super cool. Thank you.
Thanks. Super fun.
Yeah.
Cool. More talks like this, it's fun.
Yeah.
Talking about machine learning is great.
Awesome. Cheers, Carl.
Skål.
Skål.